We are delighted to welcome you all to International Conference on Emerging Trends in Engineering, Technology and Management, ICETM 2025, organized by Amity University, Noida, India. This conference brings further researchers, academicians, and industry experts to share their insights. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefits of humanity. IEEE and its members inspire a global community through its highly cited publications, conferences, academicians, and industry experts to share their insights. IEEE and its members inspire a global community. IEEE is the trusted voice for engineering, computing, and technology information around the globe. IEEE has over 460,000 members in more than 190 countries, with more than 66% outside the United States. More than 171,000 student members. 344 sections in 10 geographic regions worldwide, 2,709 chapters that unite local members with similar technical interests, 3,635 student branches at colleges and universities in over 100 countries, 4,194 student branch chapters of IEEE technical societies. There are over 460,000 IEEE members in over 190 countries, more than 66% of whom are from outside the United States. IEEE members are engineers, scientists, and allied professionals whose technical interests are rooted in electrical and computer sciences, engineering, and related disciplines. Amity University, in collaboration with IEEE, has come up with International Conference on International Conference on Emerging Trends in Engineering, Technology and Management, ICETM 2025. The objective of the conference is to address the most essential issues of the engineering, technology, computation, automation, and knowledge and management. It also serves to foster communication among researchers and practitioners working in a wide variety of scientific areas with a common interest in improvement of engineering, technology, and knowledge management related tools and techniques. It aims to bring in the academicians and practitioners to jointly discuss and deliberate through their plenary talks and paper presentations on the theme engineering, information technology, operations, and knowledge management. The conference will provide a common platform to foster research relations between the universities and the industry. The vision of the conference is to bring together technology Genesis in one venue, not only to present breakthrough research in the area of computation and automation application, but also to promote practicality and applications in interdisciplinary exchange of ideas. Now we are going to welcome our session chair, Dr. Alok Jain. Welcome, Dr. Alok Jain, sir.
Hello.
Hello, sir. Nice to have you here as a session chair.
Same. Yeah, I'm pleased to be here.
Mr. Alok Jain is Thank you, sir. Thank you for joining us. Mr. Alok Jain is a seasoned cybersecurity and financial technology leader with more than 20 years of experience across banking, e-commerce, defense, and large-scale cloud deployments. Now based in California, he combines deep technical expertise with entrepreneurial vision, excellence in securing system architecture, AWS and OpenStack-based cloud solutions, encryption at scale, and high-performance payment systems. Entrepreneurship and advisory roles. He is the founder of multiple technology ventures and current advisor to AI-driven startup. High impact projects. He has many high impact projects under his name. Architect encryptions platforms handling 10 million plus secure transactions daily. Contributed to confidential technologies for the BrahMos missile program. Core strengths: scalable security design, fintech innovation, and advanced defense technologies, and technical leadership under pressure. Thank you to have served here. Now we'll
Yeah.
start the session soon. We'll start the presentation.
Good morning, everyone. So we'll have a first paper ID, that is 134. The paper title is Investigating Sustainability Through Financing in Corporate Social Responsibility, and the presenter name is Abhijit Pavla. I invite him to please present the paper. Mr. Pavalia, are you there? Should we proceed with the second? Then we should proceed with the next. Paper ID is 13 and the presenter name is Chaman Verma. And his paper title is ChatGPT's opinion-based real-time student age group differentiation application. May I have him on the platform?
Hello. Can you hear me? Hello.
Hello, sir. Good morning.
Hello. Good morning. Can you hear me, please? I'm audible?
Yes.
Sir, actually, I think there's a technical problem. Sharing is not allowed. I don't know how to fix it. Maybe I think you have to give me the permission.
No, please check.
Yes, great, sir. Thank you. I think I am allowed. I'm going to share my PPT. I hope it will be visible to everybody. It's visible?
Yes, it is.
Thank you. So, okay, so first of all, good morning, everybody. And today my presentation topic for ChatGPT opinion-based real-time student age group differentiation application. So the paper ID is 13. My name is Chaman Verma, and I work in Department of Media and Educational Informatics and Faculty of Informatics. And university is Eötvös Loránd University from Budapest, Hungary.
Sorry to interrupt, sir. Your voice is not clear.
So right now my voice is clear?
Yes, sir. And I
Okay.
request everyone to please switch on their cameras.
So this work is basically belongs to my short project that is funded by the MIT Ministry of Innovation and Technology, NRDIO in the short here in Budapest we call. So let's start the topic. So practically, actually the project is very huge, but this is a very short idea to one experiment I did to present here. So objective is to find out the effect of the age group of the students in about the educational advantages while they are using the chat GPT. So I created two hypotheses. First hypothesis is a null hypothesis, which is show there is no significant difference or effect of the age group on the educational advantage of the using the chat GPT. And alternative hypothesis is also created because we have to be accept or reject. So this is also important to include. So that's why I created. So this is from the research point of view. And if we talk about the development point of view, so I try to create a short application which can have the results, all statistical results in the short web application. So this is a very short article, I think. So now I want to show you everybody that this is the short design or framework, how it works actually. So practically here you can see the left side here, there are some questions or queries which I asked to my own informatics students. And I have given them the survey and questions, questionnaire. So then they have given me the responses. And I try to analyze that opinions. And then I applied some statistical techniques, which is important to find out some impact. So here you can see I applied the one-way ANOVA because I have 4 groups here. And also I try to apply the parametric test to KHSD. That is also important to check where is the actually difference lies. And then I also try to find out the effect. What is the major effect for difference? This is important to prove the results, I think. And all the results are embedded into the applications, which is here you can see in the bottom right side, right corner. This is the application. We can see the results easily. So here I put a short pictures here that is from the AI generated picture. This is not the original one. So that's the informatics students. I put it here. So this is basically the idea. And now I want to go for the little bit.
Dr. Chaman,
Yes.
you please enable your webcam as well as put your PPT on presentation mode so that it content is visible properly.
Okay, so I'm going to go over there. So should I switch on my camera, right?
Yes.
So I'm audible right now?
Yes.
And
Audible
visible as well?
visible to all.
Visible? Okay, great. Now I'm going to share my screen, right? Or just a moment. It's here. Now I think my screen is visible.
Yes.
And the PPT is also visible, right, sir? Okay, so let me continue, I think. So let's see. Now it's okay. I put in the slide mode. It's okay.
Yes, yes.
So I think it is good. And let's try to brief the results here. So practically this research is quantitative plus a little bit experimental. And I can also say some development part is also there. So practically, I collected around 166 samples. Basically, these all samples from my own students from where I'm basically teaching. So I put the interval scales for 1 to 10. So around 9 features try to evaluate it. But actually there was more than features, but try to the moment my focus on the one target variable, that's why I put it here. Alpha value, that is the Cronbach alpha, that is important, which is showing above 70%. So 78 for the 9 variables. So that is okay. That's why I try to evaluate the samples. So experiment to experiment I have applied. So the language which I use, the Python language, I use all the experiment in the Python. And the technique which I applied, one-way ANOVA and to KHGS test and Cohon D, that is effect size. And here the test variable is only one, that is the chat GPT advantage. What is the advantage? And under this variable, I have a 9 sub variables, which I discussed above. And how I evaluate the results, Cohon D value and the F ratio and P value and the mean difference. Here you can see some statistical observations here, that is the median, mean, and dispersions here. So here you can see this is actually after removing the outliers. After removing the outliers, I try to show the results here. So basically here you can see the clear center tendency. About, you can see here around who are mature, example more than 26 age, and in between 26 and 30 age group, they like the most ChatGPT, but as compared to others, they don't like. Yes, they like, but they, as compared to them, they are not liking that. So here you can see the distributions, that is show the normal distributions here. You can see here most responses basically tightly clustered around the mean score of around 3.7 here. That means around 4 they are going to likely the ChatGPT in educations. And the standard deviation is a low. That means we can see this is a correct samples and very less consistency over there. Inconsistency is very less here. So that's why I try to plan for apply the parametric test, that is the one-way ANOVA, because these assumptions are important to fulfill. And here one more, two more assumptions are here. That is the normality, where there is a popular test, that is a Shapiro-Wilk test. I try to apply here, and I try to find the samples are normal here. And equal variance, that is the 11A test, also I applied here. You can see actually in the beginning, you can see I have a age group around which are 18 to 28 age group. I have a 93 people's students are there, but other groups unfortunately I found a very less students. But for apply the test, I need to make it balanced, but I don't want to apply any third technique. So better to collect the random sample, that is 18 or 16 samples from each group, so then it can be balanced. That's why we have to prove the good results. So here you can see around 68 normal samples selected for the experiment. So basically, I'm not going into the detail about the technical. I think everybody aware about it. So that's the ANOVA equations, basically general equations here. And this is the Tukey HSD equations over, that is the honestly significant difference, which basically tell us about where is the real difference. Basically, it compare the more groups together. And also I try to apply the family-wise error rate. That means 95% confidence. That is important to use it. And what is the effect Cohen D effect size is applied? I try to apply it manually. There is no basically inbuilt functions in the Python. That's why I try to use the NumPy NP. So that's why I try to create it. Okay, now I'm going to show the basic results. I think here you please try to see, this is the average of the samples of the 4 groups here. You can see the ANOVA test applied, and it is showing the value is significant over here. That's why we can see the age group of 22 and 25 has a major significant difference than age group of 26 and 30. And the second, you can see also here, age group 18 to 21 also has a difference, but it shows a minor difference, but not a significant, but it is a minor here. And below you can see the black screen here, that show, I put it in the red color, that show it is a true. That means we can reject it here. That means there is a significant difference in two age groups actually. So it is shown by the 95% confidence interval here. So overall here you can see the students who are more mature, mean to say about 26 year age, they are liking the ChatGPT more in my faculty here. And now this is again I try to show, because in the beginning we have created some hypothesis here, you can see. So null hypothesis, I must reject it based on the p-values less than 0.05. So practically there are difference I found between two groups. And yes, if it is rejected, I have to propose the alternative hypothesis for the public. So that's why it is important to accept it here. And the left side, you can see these 4 groups are no major differences here. So that's why null hypothesis need to be accepted here. Okay, so alternate hypothesis oppositely I have to be rejected. Now this is the graph here. Practically red bar will show us here the difference actually, which actually I find out here. So between the 2 age groups here, and other age groups has not a difference actually. So Cohen D effect size is also find a significant here around 93 0.93% here, and 1.07 for the both groups. You can see that means there is a strong effect actually. And here the application right now, I'm talking about the applications here. So application basically, I have this input file, which I use this input file, and input file it was in the Excel file. So advantage of the ChatGPT, that is a continuous sample because it was the rule to apply. And the target test variable has the nominal, where we have 4 classes here. And you can see here, these are the sub variables over here. And I try to create this input file and I put it in my application. This is the shorter interface of the application, which I created in the Python with the Gradio toolkit, which is very easy to use and easy to build the applications for interactive applications. And this is example for everybody user, any user can use on the mobile, and any user can use on the desktop everywhere. And here you can see this is the part, and just user has to click on the generate button. And after generate button, you can see here the result will be display whatever I show in the whole presentation. The whole results can be displayed on the short web applications. And this short web application is running on this link, that is a Hugging Face. I think this is the most popular website right now where we can apply the machine learning models. So here I put it over here, and all the graphs and all the statistical summaries are displays over here. Okay, now I want to tell the conclusion. So conclusion here of the this whole short presentation, that basically it is automating the input file and give the results, statistical results on the application. This is the development part. But from the research point of view, we find a basically difference between the two groups actually, which is proven by the one way ANOVA here. And also it is validated by the post hoc test, that is the 2K-HSD test, which show the two groups are really significant difference. And Cohen-D is also proved that there is a strong effect. And how we can see this is basically real-time visual analysis, which every institutions or anybody, maybe parents or maybe students, or anybody can see the results very easily. Where is the results lies? Okay, and what is the need for that? The need for that, for example, older students who can interact with the complicated debates and problem solving activities, so maybe the younger students can get simplified explanations well. So because they are not liking the ChatGPT more. That's why mature and how to say experts, or maybe who are maybe master students, they are using the more ChatGPT as compared to the maybe bachelor or maybe the less mature or the younger student. So thank you for your attention. I think it was my short planned work which I wanted to present today. So thank you very much.
Yeah.
Thank you, sir.
It's for the hello.
Thank you, sir, for presenting. I now like to invite Mr. Alok Jain, sir, to ask any questions if he has, and also all presenters or the one participants to ask any questions if they have.
Yeah, it was really nice presentation. I have a question regarding a sample size.
Yes,
So
sir.
sample size was around 166, and
Yes.
most of data is a hypothetical, right?
So
So
sir, data is not the hypothetical. Data is the primary data. It is original data, right?
okay,
And sample sizes you can see here around 166.
right.
And in this technique, I couldn't use 166 because I need to find the normal samples. So I try to filter out. I put it here. 68 samples I try to use, sir, actually, out of 166. So I know this is not a huge samples, but for sure the significant results, I think it is enough for 70 samples are enough, because here we have not such a more students around 300, 400. That's why I try to use it.
So do you think, the different age group with the same set of the data is apple to apple comparison?
Sorry.
With a different age group, is it like a apple to apple comparison or what? What I
No.
mean here.
What do you mean by the apple, sir? Sorry, I don't understand.
So, okay. So what I mean, a different age group have the different mindset, right?
Yes, sir. Yes.
So different age group, the same question is not valid for the different age group.
Hmm.
So
Sir.
just to
Mhm.
normalize those things, it should be, some way to make sure the same thing is applicable. Not same thing, is a different thing which have the same meaning.
Yes, sir. I understand your question. I think your idea is to be make it standardized or normalized, right?
Yes,
So,
the different.
you're right. Usually, I work because, as per my experience, because I work in machine learning topic as well. So, in that
Mhm.
case, I think this is a good idea to normalize the standardizations. But here, I think because first of all, I have to prove that these samples are coming from the same populations, and how to say reliability of the samples are adequate, which I show by the Cronbach alpha value. So I think it is a very robust test which is proved that no need to apply this normalization and other stuff. But your idea is okay, but when we apply any machine learning model and deep learning model,
Mhm.
then it is important to apply normalization and standardization as per my experience and my knowledge, as I know.
But the sample size is very less.
Yes, sir. I'm agree with it. So because here, yes, I can apply another technique that is non-parametric. In that case, I can use all 166 samples. But the problem is here, you can see, uh, because bachelor students, which is younger, are more populations here. Because in masters and PhD,
Mhm.
we have very less. So I try to manage with 2020. But sure, in the future, it can be enhanced more about 1990, but at least the results are okay. But in the future it can be possible to apply, and it can be more generalized for the public.
Okay, thank you to explain me. Yeah.
You're welcome, sir.
I have one question, Chaman Verma ji, Dr. Chaman.
Yes, sir.
Okay, it's a wonderful presentation on the usage and liking for ChatGPT. But my question is, why are you considering age group as nominal data?
Yes, sir. Your question is very right, and I'm agree with you, because nominal data is okay, because uh, in my because in my project, in the beginning, there is not a only age group uh, target variable. There are a couple of target variables, test variables. Sure, there are explainable variables are most, but here I didn't ask the student what is your specific age, like a discrete value here. So because my you know target was to go for the actual range of the students here, because that's why I created some groups here, and four groups I created practically, because in the project in the beginning we wanted to focus on the specifically age group, not for the single age actually. So that's why I
It should
used
be
it.
ordinal, I think.
Hmm?
One more question, what is your dependent variable? What have you
Dependent.
measured? What have
So,
you measured?
sir, dependent variables here. This is the Chat GPT advantage here. I think this is the dependent variables over here. So practically,
How
this is
have
a
you measured
test
this
variables.
ChatGPT advantage?
Yes, sir. This is actually one feature I given the name, but there are under 9 sub variables over here, 9 features here.
Features.
Yeah,
So,
maybe variables. You can see variables or features, whatever you can consider in machine
so
learning. We call the
what I
features.
understand, if you, I mean, there was an option to select one of the features or more than one of the features. Am I right?
No, sir, because here I created only one major feature or major variable, that is the chat GPT advantage. By creating the average of all values, because in the test there is a condition, we need the how to say continuous value right here. Can you see here? Here, can you see right now in this column?
What are the values? Can you read it out? I can't, it's not visible clearly.
Here, this is a continuous value here. That is a metric here, metric variables here, right? Scale variable. This is on the 11 slide 11. I think it is visible to everybody. Because I cannot apply the, this is actually assumptions, important assumptions of the one-way ANOVA, otherwise we cannot apply.
So it is a continuous variable, you're dependent
Sure,
variable.
because this is a rule. We cannot apply the nominal directly.
But age group, I think you can maybe think as ordinal and still.
Yes,
the
okay, sir. Yes, sir. Yes, sir. You are right. It is ordinal. You are right, because it is a rank 1, 2, 3. Okay, but in a statistical theory, we call it. It is comes under the nominal category here. But it is okay. We can other way. We can we can call.
It is categorical and non-categorical. Okay, not nominal. Okay, I mean, this is the only thing that I wanted to know.
Thank you, sir.
Well done.
Okay, sir, I also would like to highlight something that you have mentioned age group everywhere, but you have not mentioned who these students are. Are they college going students or they
Yes,
are school going
thank
students?
you. Thank you very much, madam.
And
Actually,
also from
you are
which
right.
geographical
I think
location you have
I didn't
collected the
mention
students?
here, but I speak in presentation. I think these all students are from my students, actually from my faculty who are learning the course here in computer
They are
science,
UG
informatics,
students or
from my faculty. This population from my faculty.
Thank you, sir. I like to just, make some announcement that presenters please adhere to timings, that is 7 minutes to present your paper and 3 minutes for Q&A. And only the paper presented will be presented to publish at IEEE. So now I request paper ID 221, real-time vision based risk of fall detection using YOLO V8 by Fawaz Ali. Please, sir, may I have you on the board?
Hi, am I audible? Am I audible? Hello.
if you are audible,
Good
you are
morning, sir.
please carry on.
Yeah.
Yeah, sure. This was great. Greetings, everyone. My name is Fawaz Ali. I'm a master's student at Bradley University. I'm here to present a real-time vision-based risk of fall detection using YOLO V8. My co-authors are Dr. Sharif, Sai Gautam Kaleti, Dr. Muhammad, and Dr. Mahmood. So this is the outline that we're going to go over. To start with introduction, the first question is, why fall even matters? Why fall detection even matters? To understand the impact of our solution, let me give you a little background how it all started. Picture this: a quiet hospital room, an elderly patient shifts to the edge of the bed. No one sees, no alarm sounds, and the patient falls down. Falls are not just accidents. The damage is done, and that basically increases the cost for the patient. A single fall can double the recovery time and increase the healthcare cost dramatically. Talking from a statistical point of view, according to Center of Diseases Control and Prevention, more than 14 million older adults report fall every year. The following diagram that you're seeing on the screen is basically a geographical distribution of fall across various states in various states in US. It basically shows how important it is to have a proper solution for falls. Moving ahead for the related work section. So there is already some work done in this aspect. So the complete work can be divided into two broad categories. The first one are sensor-based solutions, where people have used wearable sensors like watches and pressure mats, which are kept under the bed of the patient to detect fall. And for the vision-based solutions, people have used various type of cameras and different machine learning techniques to enhance and build the system. The proposed system that we are designing is a vision-based system, and we are using a technique called YOLO V8. So our system is basically trying to answer some of the existing issues that the previous, existing work has. So the major issues in vision-based system is computational load, real-time effectiveness, and privacy concerns. And for sensor-based systems, it's wearing compliance limited to one person, basically meaning each of the patient needs to have its own sensor, and installation and calibration cost. These are the existing problems in existing modalities that our system is trying to solve. Objectives and contribution. So the objective, what we want to do is basically design a lightweight, efficient RGB vision-based fall detection system that can be hosted on any kind of lightweight devices, let's say like Jetson Nano. We are achieving this by using a lightweight, accurate algorithm called YOLO V8, and thus enabling us basically to host on lightweight devices like Jetson Nano. Coming to the section of system design and overview. Let me walk you through the basic flow chart to understand how the system is actually working. The input image is given to bed segmentation and pose estimation phase, where basically it calculates the corners of the bed and the key skeletal points. From that module, it's passed on to the feature extraction module, where we are calculating the features and then feeding it to a classifier, which then will make a decision if the patient is at a risk of fall or not. The first important question is, what is the data that we are using? So we basically have two main classes, fall and not fall, and the data is broadly classified into two main categories, real images and 3D animated generated 3D generated images, which are Blender images. So for the real non-fall images, we are using SLP dataset, which is a publicly available dataset. And for fall images, we have captured our own data, real images, and we have also generated 3D animated images. We are using SMART to balance the data and basically enhance the YOLO V8 model. So this is the system architecture diagram. We have the input data. We are passing it to YOLO V8 segmentation phase, which then passes the results to feature extraction phase, and then to the classifier, which basically makes the decision if the patient is at a risk of fall or not. Let's dive deep into each of these phases and understand what's happening. So the first crucial phase is YOLO V8 segmentation phase. So the image is being passed to this phase, and what we are basically asking YOLO is try to identify the four corners of the bed as well as the key skeletal points of the human body. Once we have that, we are passing that data to the next module, which is feature extraction module. So here, this module gets the four corners of the bed and the key skeletal points. For each of the skeletal points, what we are doing is we are trying to calculate the distance between that skeletal point and the four edges of the bed. We are doing that for all of the skeletal points and basically making a feature vector. Once we have the feature vector, we are feeding it to a classifier, which then makes a decision if the patient is at a risk of fall or not. Coming to results and discussion. So the metric that we are using to evaluate our system performance with the existing systems is EAR, which is basically efficiency to accuracy ratio. What it basically means is how effective and what kind of computation load is our system costing us, as well as what kind of accuracy it is giving us. We calculated that for our system and other systems. I'm proud to say that we beat other systems by 30 to 40% on a margin. Diving deep into the result section, so basically for the classifier phase, we tried 4 different classifiers: SVM, decision tree, random forest, and XGBoost. XGBoost outperforms all of them. Comparing our results with other existing work, here you can clearly see the XGBoost with an accuracy of 99.66 is outperforming all of the existing work and giving us accurate as well as effective system. With this, I would like to conclude that our goal was to design effective and accurate system which can be hosted on any kind of lightweight devices like Distant Nano, and we are able to do that. That's it from me. I would now like to open the phase for questions, if any. Thank you.
Thank you, sir. It was very nicely explained. Now I request paper ID 28. And if there are any questions, please ask the presenter.
Hi, Fawaz. Yeah, it's a nice approach. So I want to understand, as you mentioned, it's a basic, fall in the US,
Yeah.
right? So, but the most common fall in US is in washroom, person go
Yes.
for a shower and just fall. So that's a very
Yeah.
common fall.
Yes.
And in the hospital, they have a bed which already have a protection all around, so that patient, should not fall in
Yes.
any of the direction.
Yes.
So in what circumstances do you think, this is applicable?
Yeah, that's a good question. So generally, the problem with the beds that have these kind of things on the edges is basically patients are not very comfortable. They feel more of like trapped kind of thing when patients you raise the boundary and stuff.
No, for us in the US,
Yeah.
it's a very legal no,
Yeah.
right? So it should have that. So it's not depend upon the patient, it's depend upon the rule and regulation.
Yeah,
Right.
that is
So
definitely. Yeah, go
because
on.
the hospital want to protect the patient,
Yes.
If they don't want to give an opportunity, that someone will see it, when the person is about to fall. So I just want to understand in what use case it can be a novel approach for
So
application.
definitely, that's a valid point. So what I'd like to say here is this approach that we are designing is more of a prevention security based approach. Okay, so we are basically trying to prevent the fall. So not all the bedges, not all the patients have those kind of things. Okay, let's say a general ward or something like that. So basically, you can just have a camera that's going to monitor everything, and if there is any kind of fall.
No, for us once again, there is no concept
Yeah.
of the general ward. The bed are like that only, is a protected bed.
Yes, I mean, not all beds are protected. That's what I can say. So we are basically trying to design a system where, in
Uh-huh.
the dream scenario, like in our scenario, where the bed is not having that kind of thing, and you have a hospital or you have a clinic, and you are trying to detect fall on it. Okay, you basically want to have an alert system on it. That's where our system comes into play. That's the domain basically we are trying to sell.
Okay, so fair enough. So in that case, you should have one more domain in that a notification or someone who should monitor it.
Yeah. So
Right.
basically,
So
in the hospital cases, those are the nursing stations, right? A dream use case would be if there is a bed where you don't have that, and there is a patient very close to the edge of the bed, and basically in the nursing station, it gets alerted saying that in so-and-so room, the patient is very close to the edge of the bed, and you can just go and check before the patient falls. That's a dream case.
Okay.
Okay, hi Fawaz. First,
Hi.
a very good presentation.
Thank you so much.
And second thing, my question is, which configuration specifically have you used for YOLO V8? Like, is it N or S or any other?
So basically, we have used segmentation module, which is provided by Ultralytics, which is an open source library, and they give the segmentation thing. So what segmentation basically means is, in an image, we are trying to identify every part of the bed every part of the image that belongs to the bed. Okay, so that way we are able to completely understand what the bed is, and using Python scripts, we are able to calculate the most corner coordinates of the bed. That's how we are able to get the 4 corners. That's what we are doing. So for we are using segmentation for the bed module, and for the skeletal points, we are using the module which is already pre-trained on Coco dataset. Okay, it's trained on Coco dataset. We are trying to identify those points, and once you have the data, we are passing it to the feature extraction module.
So what exactly are you trying to do? Like, for example, you have detected that, yes, these are the dimensions and the person may fall from the bed. What after that? How your technology is going to save the person from falling?
So the core idea is, as I just mentioned, if our system detects the fall, the idea is to basically notify a nursing station, notify whoever basically is using the camera, basically notify it saying that the person is about to
So
fall.
that
So
can be
the folk
immediately attended. This is
yeah,
your
so basically attended. And the idea is, the paper is more focused towards enhancing the system, not the end application. So it can be used in any way, but our focus is on enhancing the system, not how we can connect it. It can be connected in multiple ways. It can be
So
connected
have
in
you
hospital
tested it
system.
already, or is it just in the plans?
So we have tested it on our data sets that we have, but we have not performed clinical validation.
What was the accuracy?
With the XGBoost, we are getting an accuracy of 99.66.
Oh, that's pretty good.
That's great. Yeah. So we have tested on the real world images that we have taken in a controlled environment. We have tested that, and based on that, we have the results.
Okay, great work. All the best.
Thank you so much.
That was a very well structured and enlightening presentation. Now I invite next presenter, paper ID 28, predictive analysis on brain tumor detection using machine learning and meta heuristic algorithm by Aditi Gupta. May I have you on board, please?
Good morning, everyone.
Yeah, good morning.
Okay. So I am Aditi Gupta, and currently I am in the 8th semester of BTech Computer Science. And today I will be presenting on the behalf of my group on our paper titled Predictive Analysis on Brain Tumor Detection using Machine Learning and Meta Heuristic Algorithms. To begin with the introduction, first we would talk about the brain tumors. Brain tumors are a critical medical condition that affects millions worldwide. MRI imaging provides high-resolution, non-invasive scans of brain tissues, making it essential for tumor detection. MRI images are available, but to assess these images and to understand whether the person has tumor or not is difficult. Accuracy is not 100%. So artificial intelligence techniques, especially ML, can automate and enhance diagnostic accuracy. This project combines machine learning and meta-heuristic optimization for an efficient and accurate detection pipeline. Problem statement. So we believe that if we detect the tumor at an early stage, we can cure the disease better. And the challenges while detecting the MRI images are the high dimensionality of image data. The data set is of very high dimension. So to So to apply algorithms on these images is quite difficult. Time consuming and error prone manual diagnosis, lack of consistent performance in existing AI systems. So that's how we got the motivation to compare all the algorithms that are present and all the algorithms that are currently in use to get a clear understanding of what algorithm gives us what result. These are the research gaps that we discovered, that existing solutions often rely solely on ML or DL and not a combination with meta-heuristics. Lack of attention to computational efficiency in high-dimensional feature spaces. Many models underperform on unbalanced or limited dataset, and there is no standardized pipeline as to which step should come after which step. These were the objectives that we kept in mind while conducting our research. To conduct a comparative analysis, to improve classification accuracy by using advanced feature extraction and optimization, reduce computational complexity using feature selection algorithms, and evaluate the performance using multiple metrics, including accuracy, recall, and FN score. Now coming at the literature review, we saw that CNN-based models like DenseNet 201 and EfficientNet B0 achieve high accuracy up to 95.7% in tumor classification. UNet and its variants, for example, attention UNet and ResUNet, are used for segmentation with high precision. Transfer learning with pre-trained models like VGG16 and ResNet 50 shows excellent adaptability even with limited dataset. These models excel at learning hierarchical features but requires large data and computing resources. Meta-heuristic algorithms like genetic algorithm, Harris-Hawks optimization, particle swarm optimization, and biogeography-based optimization are widely used for feature selection and hyperparameter tuning. These are used for enhancing the classification process. Hybrid strategies such as gray wolf plus salp swarm show potential in balancing exploration and exploitation effectively. Now coming at the feature extraction techniques, GLCM, GLDM, LBP, and SIFT are used to extract comprehensive features from the dataset. Hybrid models combining multiple feature types outperform single method approaches, and that's why we prefer hybrid approaches most of the times. Dimensionality reduction techniques like PCA and wavelet transforms improve efficiency. Fractal-based and statistical methods provide deeper insights into tumor boundaries and morphology. Now coming at the methodology. So we began our process with data collection. We took a 290 labeled MRI images dataset from Kaggle, which is publicly available. Then we began with image filtering, basically removing the noise from the data. We used 3 filters, mean, median, and Gaussian filters. Then image segmentation, we used 2, also thresholding and controlled watershed. To extract the features, we used GLCM, GLDM, LBP, and SIFT. For feature selection, here we have applied meta-heuristic approaches. We have used almost 20 algorithms to compare, which includes whale optimization, genetic, hybrid, gray wolf, and SALP optimization, and many more. And we have classified the results using ANN and KNN models. And we have evaluated our results on basis of accuracy, precision, recall, and F1 score. Now let's look at the technical details of methodology. Filtering is done to remove the noise from the tumor edges, preserving tumor edges. Mean is used to smoothen the images. Median filter is used to handle salt and pepper noise. Gaussian filter enhances visual clarity. Then we have done the segmentation to separate tumor from brain tissues. Also, thresholding provides binary segmentation. Controlled watershed refines boundary accuracy. To extract the features so that we can collect relevant data, meta-heuristics is used to reduce dimensionality by selecting high-impact features. They basically use natural-inspired algorithms like BAT algorithm, particle swarm optimization, and many more. And classifiers are ANN and KNN. ANN is flexible and nonlinear. KNN is simple and distance-based. Coming at the results, so meta-heuristic algorithms yielded varying number of selected features. Like genetic algorithm gave us 35 features, HGSO, that is hybrid hybrid, gray wolf, and swarm optimization gave us 36 features. Whale optimization, CS, BAT algorithm also performed well. Algorithms like PSO and MVO failed to select relevant features. They also were not very up to the mark during ANN analysis also. So this showed us that optimal feature selection directly impacts classification accuracy and computational load. Okay, so these are the ANN performance metrics. So the top performers were genetic algorithm, accuracy was 70.59%, and F1 score was 76.19%. Whale optimization algorithm, high recall value of 79.31%, and HDSO balanced performance with F1 equal to 76.92%. If we look at a broader perspective, genetic algorithm and HDSO gave us a balanced performance metrics which can be used. We observed that feature selection improves ANN's tumor prediction by focusing on key areas. Just a second. Okay, moving on with KNN performance metrics. So whale optimization and ABC gave us an accuracy of 72.54% and F1 score of this. Simulated annealing gave us an F1 score of 77.41%, which is the highest. And KNN benefited from fewer but well-selected features, maintaining high sensitivity and specificity. Algorithms like MVO again performed poorly, and we can see this graph. So here we can see that we have evaluated on the basis of accuracy, precision, recall, and F1 score, and the results are shown. To conclude my PPT, the hybrid model efficiently detects brain tumors with improved accuracy and reduced computation. Meta-heuristic based feature selection is crucial for optimizing MLDL performance. The proposed framework can be extended to other medical diagnostic tasks. It supports the development of reliable AI-assisted diagnostic tools for clinical use. And in future, we can integrate advanced CNN structures, architecture for end-to-end learning, explore transformer-based models for spatial feature representation, and the dataset that we took was a smaller dataset. We can take a larger dataset and a real-world dataset for training and validation, deploying the system on edge devices for real-time diagnostics, and addressing regulatory, ethical, and performance challenges in clinical environments. Thank you.
Thank you, Aditi. Thank you for your insightful presentation. It was both informative and engaging. I invite our session chair, Alok Jain sir, to have questions, please. And
Oh,
participants.
yeah. Aditi, is really nice explained, and you really use number of the approach. I have one question. What is the smallest size of the tumor is detected by, all the approaches, combined approach? Do you have any?
So actually it begins with extracting the features. So it depends on the feature extraction. Like we have extracted 36 features. The amount of features that we extract is currently proportional to the accuracy of the brain tumor. So if the features are extracted less and the brain tumor is more, so it will give the relative result.
No, my question is related to what was the smallest brain tumor size which detect with the high accuracy?
So 1 mm.
1 mm. Okay. Yeah. Thank you so much.
Thank you, sir.
Yeah. So just want to add one more thing. Nowadays, what they're doing, a lot of companies doing a blood test.
Yes.
So blood test base, they are trying to detect tumor before it occur, before 1 year or 2 year. Right.
Okay.
So the blood test is also going on the same end. And of course, if someone have a brain tumor, it's really a good approach. Yeah.
Yes,
Thank
sir.
you so
Our
much,
focus
Stuart.
on MRI images. Yeah.
Yes,
Okay.
Aditi, indeed, it's a good approach and it is a good thing that you're trying to do. I just want to ask at which meta heuristic algorithm specifically you have used for this?
Ma'am, we have used 20 algorithms, like 20 meta-heuristic approaches, but genetic algorithm, hybrid, gray wolf, and swarm optimization, and simulated annealing, they gave us the best results. So these were our top
And
performers.
what was your data set on which you have applied it and you have seen that the results are good?
So, sir, so ma'am, these were 290 images, MRI images data set.
From where did you get those 290 images?
From Kaggle. It is publicly available.
Or is it's in open source data?
Yes, ma'am.
Okay. So what was the accuracy level?
So ma'am, accuracy is for two models, KNN and ANN. For KNN, we got 70.42%, and for ANN, we got 77.98%.
Okay. Okay, fine. Thank you.
Thank you, ma'am.
Thank you so much.
Thank you.
Moving ahead. The next paper ID is 34, Optimize Data Packet Routing in Vehicular Networks Using Edge Intelligence and GNNS by Rajesh Daruri. May I have you on board, sir? I suppose he's not yet joined the presentation. Let's move ahead with paper ID 37, Lung Cancer Detection Using a Custom CNN by Anantavali and Soumya Singh.
Hello, good afternoon.
Hello, good afternoon.
Am I audible?
Yes, ma'am.
Yeah, so just give me a second. Sorry, can you please share the screen?
Yeah. Just a second. Is the screen visible?
Yes.
Yes, visible.
Yes.
Okay, so good afternoon, everyone. I'm Anantavali, and I'm here with Soumya Singh to present our research on lung cancer detection using a custom CNN network. We both are undergraduate students from the Department of Computer Science and Engineering at Amity University. So this work has been a collaborative effort as a part of our academic and research journey. And we are excited to walk you through the approach. So talking about lung cancer, it is recognized by the World Health Organization. It's one of the top cause of the cancer-related deaths worldwide. Unfortunately, it's often diagnosed when it's already in the advanced stage. And by that time, the treatment options often become limited. And hence, there are a lot of deaths related to it. So this highlights the importance of the early screening, especially for high-risk individuals. So if we catch this disease early and if the tumor is detected earlier, we can dramatically improve the survival chances. That's why the work that we have done, it focuses on building AI-based tools that can help us detect the lung cancer early. And not just early, moreover, quickly, accurately, and most importantly, efficiently. Now, let's talk about the gaps that inspired our research. Firstly, many existing models, they are not specifically built for lung cancer. They are more like generic combination of models, which limits their accuracy. Secondly, mostly rely on their pre-trained networks, which, while they can be powerful, these models are usually trained on very different data sets like ImageNet, which often don't perform well on medical data. Third, there's a lack of models that can effectively detect features of various sizes, like what I mean to say is the different sizes of tumors that are very easy to miss. Finally, there are a shortage of smart hybrid design that combines CNN with advanced features, extractors like the Inception model. That's where our model comes in. Okay, so our project had mainly 5 key goals. First was to build a custom CNN that's specifically optimized for lung cancer detection in CT scans. Secondly, we used an inception model in our block. They can help us capture features at different sizes, which is essential for identifying both small and large tumors. Third, we wanted to make early detection more accurate because catching cancer can lead to better patient outcomes. Fourth, we focused on reducing overfitting by improving how the model learns features, especially on small and imbalanced data sets. And finally, we validated everything using a publicly well-known lung imaging dataset to ensure that our model works beyond just theory. Okay, so next, to train and test our model, we used two widely recognized datasets, that is LIDC-IDR and Luna 16. These contain CT scans with expert annotated labels, including both benign and malignant nodules, or if I tell in easy language, cancerous and non-cancerous. Once we had the data, we performed pre-processing. So all these scans are stored as DCOM files, which were converted to medical standard Hounsfield units for consistency. We also narrowed down the slice for each patient. So out of nearly 180 slices per scan, we selected the 100 most relevant ones, those between slice number between 50 and 150, because that's where the lung tissue is the most prominent and meaningful for analysis. This ensured that our model focuses only on the important parts. Now handing over to Soumya.
Now continuing, for a lung segmentation, we have used watershed algorithms to remove irrelevant parts like bones and body tissues, etc. The data format is HW1, where H indicates height and W indicates width, where the height and width are 512 pixel size. So each image is labeled as cancerous and not cancerous based on the annotation. As you can see in the diagram, for model architecture, we have used a combination of 4 convolution layers and 2 inception blocks in the architecture diagram. So for model training, we have used around 1002 images having for 12 patients, where 100 images are for per patient. So out of that, 901 we have used for training and remaining 100 for validation. For loss function, we have used binary cross entropy and Adam optimizer. As you can see, for evaluation matrices, we have used training accuracy and loss and validation accuracy and loss. So for our analysis, we found that our custom CNN model has a high training accuracy of 97.45%. We trained it on a 30 box and 32 batch size. So the validation accuracy is 93.04. Which is close to training accuracy and shows that our model is good in generalization. The training loss is 0.0427, which is low, which shows that our model effectively minimized the errors. So as you can see in the graph for the 30 epochs, we have got the high training and validation accuracy. So the main findings were that our model generalizes well, and inception block was effective in finding out multi-scale feature extraction. Also, since we are using CNNs, our model is compared to other models comparatively lightweight and computationally efficient. So in the future work and implications, we can see it helps in improved early detection because inception block is capable of, finding intricate cancer cells from the CT scans. Also, I forgot to mention that the general CT scan is of 180 image sizes, and we found that the most relevant slices in the images where the cancer cells are found from 50 to 150. So we have used those slices. Our model is lightweight and deployable, as I mentioned before, and it is definitely scalable for real world use, so it can be scaled up in the future work. And the most important part is it can help doctors in remote healthcare. It can be incorporated into telemedicine platforms, and remote diagnosis can be made possible. So clinical adoption is there in the future. With that, I conclude my presentation. Thank you.
Thank you. Thank you for such a clear and thoughtful presentation. I invite our session chair, Alok Jain, and other presenters to ask questions. Thank you.
Yeah, thank you so much. It was explained really in great detail. So you explained some of the future work. So which one do you think is a more priority? Is to train with a more data set or?
So I think definitely we should train it with more data set, because in a real life scenario,
Mhm.
we will deal with a lot of patients. So it should be extended to a large number of data set. But since we used our common laptops from home, so we used a small data set to generalize and give an idea of a custom model, but it should be definitely integrated for larger data sets.
Adding to what
Okay.
Soumya said, our main future work will definitely be including more data set images. But our main aim was to make a model that is more computationally efficient. So
Mhm.
and our main aim also would be to test this model more, so that we can identify if there are any issues that lie behind, and we can fix that, and the model generalizes better.
Okay. And the last question is, um, the accuracy depend upon the tumor size, or irrespective of tumor size, accuracy is the same?
Sir, we have just used a classification model, so the general accuracy was taken out.
Okay. Thank you so much.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you. Now I again invite paper IT 3-4, optimize data packet routing in vehicular networks using edge intelligence at GNNS by Rajesh Daruvari.
Yeah, hi.
Hello, sir.
Yeah, hi. I'm audible?
Yes, sir.
Yeah, thanks. I'm sharing my screen.
Sir, please switch on your camera.
Okay. You can see my screen, right? Yeah, is my screen is visible?
Yes.
Yeah, I would like to present the paper on optimized data packet routing in vehicular network using edge intelligence and GNN. I'm from a solution consultant from University of
Sir, your
Cumberland.
voice is not clear.
Yeah, it is clear now?
Please a bit louder.
Okay. Yes, okay. Yeah, coming to the content, here I'm going to present introduction, problem modeling with the Markov game and multi-agent learning reinforcement, and general for IoT routing, and business impact and real-world application, simulation setups and simulation parameters and hardware, result analysis, conclusion, and references. So here coming to the introduction part, generally.
Sorry for interruption, sir.
Yes.
Sir, while presenting, we would like to for you to switch on your camera.
Yeah, I already switched it on. Already switched it on. Already on it. You can check it.
Ma'am, we are not, sir, we are not able to see
Okay,
you.
okay. Yeah,
Yeah.
it's clear now, right?
Thank you.
Yes, okay. Coming to IO enhancement, safety and efficiency in urban safety using the vehicular to communications, it generally comes with respect to routing protocols and packet losses and delays. And generally, it been implemented with respect to IEEE 802.1 on P. And coming here, it generally comes with the signal authentication, attenuations, and also transmission delays, and also packet transmission mismatches. And coming to here, existing routing protocol generally comes with respect to path losses and also the different protocols which we are getting into existence with respect to heuristic methods and traffic dynamics. And also it comes with the hop level implementation and also the mixed global suboptimal approaches as well. A-based method generally comes with reinforcement. Just generally what we are doing with is reinforcement learning, and also the end part with respect to DQ networks. And also here comes with limited sensing and inter-packet coordination missing as well. And coming with here, GNN and TRL in edge intelligence architecture comes with respect to thermal delays, edge relays, and cloud layers. And here it comes with respect to latency and also long-term learning and also the environment sensing and data collection methods. Here TRL plus GNN protocol generally comes with respect to model routing and Markov gaming model, and also the routing using edge intelligence and collaborations. And here the results generally comes with respect to baseline comparison with existing methods. And coming to problem modeling, Markov gaming in vehicular networks comes with respect to traditional packet loss generations, and also it comes with respect to GNN plus transform RL. Routing is done with respect to Markov gaming using MA PPO model. And here that Markov gaming tubular with respect to agent data packets and states actions that generally we discuss with respect to state decisions or interactions, and rewards are generally defined in terms of delay minimization parts. And coming to multi-agent reinforcement learning frameworks comes with respect to proxy policy approximation, and it's is defined with respect to pi policy and also the action AI, and it comes with respect to state value and using knowledge-based methods. It is trained using centralized and dynamic actors, that is local observation and global state models, and these are things are being modeled with respect to an optimization function, that is here delta IT is equal to RIT plus gamma of this is nothing but general prediction values which we are going with. And coming to graphical neural networks in vehicular networks comes to the roads and SRUs, generally comes to models as graphs. And here GNN enables multi-hop message aggregation and also the dynamic computation at parties. And also benefits are defined with respect to connectivity patterns and routing adaptivity and accuracies. And it comes with respect to scalability and low latency things. And here, the business implications and real-world impacts that generally is defined is respect to reduced costs and traffic efficiencies, user benefits, and revenue potentials and scalabilities. This generally defined with respect to the business implementations point of view. The simulation setup generally comes with OMNet plus Venice frameworks, and routing protocols comes with GNN plus transform-based RL, and maps used are virtual maps, that is 6RM by 6RM, two-way 6-lane roads, and the real maps comes with respect to based has one, and vehicle trajectories are assumed generations. Generally, it speeds are 20 meters per second, and communication power is 18 milliwatts, and the range is given as 600 meters, and the vehicle hours it could be 8 milliwatts, and the range is 300 meters. Agents could be 15 data packets with random source and destinations. And simulation parameters and hardware, what we have used is maps is just what we have discussed here, and we are summarizing the overall things. And here, edge cloud deployment and the processors, what we are using is Intel Xeon Platinum 8286, 8268, and also the NVIDIA RTX 4080. And cloud deployment could be GNN plus TRL training models, that is RSUs, remote RSUs, edge servers, and distributed routing strategies up to the terminal by class. And coming here, results and analysis, transmission delay is lower, that is around 35.72% to 48.12%, and adaptive RL TRL plus GNN detection transmission is usually effective when compared with the other baseline methods. And reception rate could be 20.56% to 30.45 when it's compared with the baseline protocols, and better collision handled due to packet interaction modeling, and also transmission hops are generally validated with respect to the optimal distances, and also that could be 4,500 meters, and proposed could be 22. EMT could be 27, IDR 25, and DPR could be 24. And conclusion we can draw is inefficient routing in dense vehicular networks. That is one of the things what we are trying to recover it on. And solutions could be edge clouding collaboration system is very good, and key contributions could be that modeled multi-path routing as Markov game, and it is applied in real-time routing. Outcomes could be 48.12% lower delay and 30.45 higher reception rates, and scalability, efficiency, and realistic frameworks with respect to smart city deployments. These are the general things what we are going with. These are all the references which we covered it. Yeah. Any questions? So I can show you. Sure. Yep. Any questions? Generally, it's been evaluated with respect to level simulations with respect to the data which we've been collected with sim networks, and here the observations which been given with respect to the waveform analysis, that we can specify that the proposed one could be better one in terms of the existing things, that is generally compared with the emergency message transmission, interaction based distributed routing, and also deep reinforcement protocols. And it also been evaluated with respect to vehicular density on average reception in virtual mapping as well. If we see here, the proposed could be the better when compared to the existing methods as well. So here, the summary can be defined with respect to tabular evaluations, that is the transmission delay across that transmission hop, which has been specified in terms of transmission distances. The proposed could be the better one in terms of transmission distance as well. Yeah. Yeah, any questions?
Rajesh, it's really a great work. Can you go to your presentation first page, first slide?
Okay, just a second. Yes.
Go down.
Yeah.
So basically, this is related to the IOV, right?
Yes.
So here you want to enhance the IOV thing
Yes.
for safety and efficiency.
Right.
So you use the map and some other data. So did you also test it with the the map and real-time data?
Yeah, that's what we've been specifying that. We've been defined with respect to real-time data only. And the graphs analysis
Okay.
also is defined with respect to real-time data as well. So I've been summarized that one with respect to virtual maps as well. Yeah, that's also we have been verified it. The observations also been analyzed with respect to waveform analysis as well.
Okay.
Yeah.
So can you come on the result part as well?
Yeah, this one. Simulation setup. Yes.
Okay.
Yeah. Yeah, here virtual as well as real time both being evaluated.
Okay. This is really good work. What the next step in this?
Yeah, we are having one more problem because in vehicular dense network, we are having some issues. We are facing some issues. So we are working on it as well. Yeah.
Right. So this is just related to the protocol, not with the camera and the other sensors.
Yes, that's correct. So anyhow,
Okay.
one thing is cameras and sensors are fixed, right? So the data capturing could be the fixed thing. It depends on the aperture IDs and as well as the frame rates and those things. So that could be defined with respect to the camera input values. So if you go to the high-end camera resolutions and high-end cameras, the data could be the same. But here we are trying to improvise the data analysis with respect to that things. So we generally concentrating on the algorithms that how we are trying to analyze the things and we are trying to the approximate optimized things without any losses. So anyhow, if you want to go with the high resolutions also, these things are applicable. We've been testing that thing as well.
All right. So in the real world scenario, if you want to replace the real intersection with this new protocol, what the change do you need to do? You need to change some hardware or what are you planning to?
So
how
the
you
thing is,
planning to achieve it?
so algorithm whichever you use is augment based. So with respect to the technology updates and hardware updates, just the same thing will be useful. Just in terms of parameter initializations also need to be done. That is extra piece of bit we been augmented that. Okay, it can be done. These algorithm whichever is used, we can directly interface it. On top of that, the arguments which we are trying to interface the real advanced hardware to the algorithm, that interface is being modeled. So there is no much complicated thing in terms of interfacing the new hardwares.
But what I know that all the hardware are the embedded system, and they have just a parameter to change the timing and the correlation between a different light.
Yeah, that's what I'm saying. So initially, the algorithm whichever we developed is, it will be applicable to latest hardware as well. The thing is only the interface that with respect to the parameters in terms of embedded bump pins will be having, that bumps need to be configured, and that configured bump should be matched with respect to the algorithm input variable values.
Okay.
Yeah.
So
there is no much complication. So that is also it's also loop line. There couldn't be any extra efforts made on that, because as we are already working on real-time modules and real-time existing hardwares, so we've been minimizing the interfacing part as well. So there couldn't be much struggle in terms of developing that interfacing part.
So,
Yeah.
so thank you so much, Rajesh. Best of luck.
Yeah, thanks.
Thank you for walking us through such complex ideas and in simple and understandable way. Now I invite Prince Kumar Yadav, paper ID 185, Autism Prediction Model using Machine Learning Algorithm. May I please have you on board?
Yes, ma'am. Thank you, ma'am. Good afternoon, everyone. First of all, I want to start.
Yeah, please start.
Yes, ma'am. Good afternoon, everyone. My name is Prince Kumar Yadav from Department of Computer Science from Sarda University. Today, I will be presenting our work on autism prediction using machine learning algorithm processing approach in assistant of early detection, diagnosis. Introduction. Autism spectrum disorder is a development condition that affects communicational, social interaction, and behavior globally. About 1 in 100 hundreds are affected from the disease. However, diagnoses are often realized in subjective clinical assessment, leading to delays. With the rise of machine learning, we have demography to analyze the early detection. Third is research gap. Despite diagnosis is still large subjective, most studies focus on single algorithm rather than comparing several. There is a limited work on interpreter models that can be used in clinical settings. This motivates our study to explore the multiple algorithms and evaluate their truly. Our objectives. Our objective to use various machine learning algorithms to predict autism disease, to compare their performance using standard evaluation matrices, to evaluate the more accurate and interpreter models, evaluate to support clinical disease making using technology. Now, methodology. We used a data set that includes behavior, demographic. The algorithm we implemented are SBM, random forest, decision tree, logistic regression, ANN, and GBM. We evaluate their accuracy matrices such as accuracy, precision, recall, F1, and RFC curve. Algorithm overview. Decision tree. So easy to interpret but prone to overfitting. SBM good for high dimensional data but computationally heavy. KNN simple but not great for large and complex data set. NN high accuracy model through difficult to interpret. Logistic regression very interpretable. Random forest from strong performance using robust across data sets. Model analysis. Random forest and logistic regression both achieved high accuracy of 85%. SBM followed with 83% and KNN scored 82%. Decision tree was lower at 78, so random forest and logistic regression stood up as a top performers. Now, findings. Key advantages text includes random forest and KNN had high accuracy. Logistic regression was easier to interpret. KNN struggled with high dimensionality. Ensemble method like random forest consistently performed better. Now, implementation implications. This approach uses real-world benefits. It can reduce the overload of clinicals. Bias is minimized through objectives and predictions. Telehealth platforms uses it for remote screening. It uses also supports policy planning by high density risk at scale. Challenges in future work. The data set was small and imbalanced. Many models lack transparency, which limits clinical trust. Ethical concerns and privacy bias must be addressed in the future. In future, we will plan to explore the diverse data set, most interpretable as tools like LIME and SHAP SAP, and focus on ethics like AI practices. Now, want to show the conclusion. In conclusion, machine learning has a potential to significantly enhance early detection of autism prediction. Random forest and logistic research as a strong candidate for prediction, but we have ensured the model are interpretable, ethical to be used, and not as a replace the clinical judgment. Thank you for your attention. This is my work. Is there any questions?
I invite our session chair to please ask the questions.
Prince, it's really good work. Can you go, few slide back?
First slide.
No. Go next slide. Next. Yeah, here.
Challenge.
Before that.
Before finding.
Yeah. Before that. Yeah, here. Yeah. So here, you want to find out the ASD or diagnose it.
Diagnosis, sir.
So, is any diagnosis available for this disease?
Sir, I take a data set from Kaggle and pre-process the data set. The data set are imbalanced. First of all, I balance the data set and start feature to train the model which diagnoses that the patient have autism or not in the early stage,
Okay.
so that the doctors will prescribe him very well. This is my work.
Okay. And what was the input in that data set?
Input having various columns. It has a clinicals and behavior of the candidates. You can say patients. Behavior and clinical data set.
Okay. Okay. Thank you so much, Prince. Yeah.
Thank you, sir.
Thank you.
Moving ahead, I would like to invite 212 Graph Neural Networks for Advanced Financial Risk Modeling in Volatile Markets. Krishnam Raju, sir. May I please have you on board?
Can I leave, ma'am?
Sorry?
Can I leave?
Yes, sir.
Thank you.
Yeah, thanks, ma'am. Let me share my screen. Let me know if you see my screen. Are you able to see my screen?
There is a one pop-up on your screen.
Zoom requesting bypass system. Okay. It's good now.
Yeah, thank you so much.
So you are seeing that my PowerPoint, this PPT, right?
Oh, yes. Please go ahead.
Yeah, my name is Krishnam Narspalli, and today I will be presenting the paper title called Graph Neural Networks.
Sir, excuse me. Sir, can you please be a bit
Skip the
louder?
transcript and switch on to your presentation.
Sorry?
Can we just skip the transcript and straight away move to the presentation?
Yeah, presentation only I'm doing. This is the one, right? This is the screen you are seeing. Okay, let me see. Is it visible now? Is it clear? No, actually I'm using two
Was
screens.
that
Let
your
me.
presentation? The earlier screen that you shared, was that your presentation? You want to go ahead with that?
No, this is the one, the PPT I opened, right? So are you not seeing the PPT?
No, we are unable to see the PPT. We can only see the Zoom window.
Let me see.
Yes, now it is
What?
there. Yes.
Okay. I think I shared the other screen. Okay. Okay. Yeah. Hi everyone. This is Krishnam Narsipalli. I'm from independent research and I'm from USA and I work for lead engineer for TCS. And today I'm presenting the paper called Graph Neural Networks for Advanced Financial Risk Modeling in Volatile Markets. So the introduction for this,
sorry for interrupting, Mr. Krishnam. It seems that you are a bit away from your mic. The voice is coming in a very feeble manner. Can you be more nearer to your mic so that we can get a bit louder voice?
Okay, let me increase volume.
We can see your slides. These are visible, but you can make it full screen. These are still minimized.
Yeah, I'm not using headphones. Maybe let me.
Yes, now it is slightly better. Can you increase a bit more the volume? What you did just slightly more.
Yeah, it's good now.
Yes, it is better now. You can continue.
Okay. So, yeah, introduction under the problem statement is financial markets have become increasingly complex due to the globalization and high frequency trading. And the traditional models like generalized autoregressive conditional heteroscedasticity, that is called GARC, and then VAR, like value at risk, fail under extreme volatility. So financial networks are complex, dynamic, and interdependent. So that is that is a challenge to the models in systemic risk and contagion effects. So we need the approach like interpretable models, leveraging structure and the time. So the research gaps and objective, traditional ML assumes independent data points. So lack of graph-based modeling in financial risk prediction. So the objective is we are here building a GNN framework to model systemic financial risk. The approach is represent market entities as nodes and interrelations as edges. So like the graphs are like graphs are like financial systems, and the entities are the nodes, and then the correlation and interrelations are at the edges. So in this methodology, the data we use stock prices, sector indices, and macroeconomic signals. And the graph construction is nodes like as I said, this is a form are sectors, and then edges is correlations or transactions. So the models we use like graph convolutional networks, graph attention networks, and temporal graph networks. These are all the models evaluated. So the training is on the cross entropy and MAC and ranking laws used. So the evaluation, accuracy, RMSE, F1 score, and precision at 10. These are the the metrics got it, and that is also in the next slide. So results and evaluation. So these are the traditional models like logistic regression, random forest, and then LSTM. So the accuracy, the scores like if you say accuracy percent and F1. So compared to those, like whatever we proposing this GCN and GAT part of this GNN. So the more accuracy level, like 84.5% and 86.2%, and then F1 score is 0.83 and 0.85, and RMSE is 0.06, and compared to others, like the error rate is like mean square error is compared to very low. So the GAT model achieved highest accuracy and lowest RMSE. This is the and outperforming both traditional and deep learning models. So precision at 10 for top K risk detection was 0.88 for GAT at 0.84 for GCN, highlighting super precision under volatility. Key findings and implications. GNNs capture complex risk propagation and sector dependencies. And the energy financials identify as high risk sectors, and this helps regulators and investors with real-time risk assessments. Supports and it will support the systemic resilience analysis. Okay. And the conclusion is like GNNs provide robust interpretable tools for dynamic risk modeling, and the future enhancement is incorporate real-time social sentiment and news data. That is the new enhancements, and use heterogeneous graphs and XGNNs for interoperability. Integrate reinforcement learning for live financial systems. Yeah, this is out my presentation. Thanks for attention.
Krishnam, this is really nice presentation. So it was just tested on the sample data, right?
Right,
Not
right.
the live feed data.
No.
So here, how you will define the, volatility, because it is specific to the volatility market.
Right, right. We took some sample data from using Google Cloud and some setting up agents. It's very minimal data, not much. So there is like US Stock Exchange, New York Stock Exchange data, and then for the different time periods, different time ranges, we took it.
So in the first step, you just rectify the day. In that day is a volatile market. Is it so, or is just applicable to all day?
No, it's that's what it it's you mean like the volatile time, like the most volatile time periods, like the opening and then the closing time before closing opening.
No.
Then
So volatile is when there is the government policy change. There is a sudden change in the news, sudden change in the sentiment.
Right. Yeah. That
Yeah.
also, like that is macroeconomic. That is called based on GDP, and then the interest rates depends on the the bonds. So these are all
Okay.
like we considered all those things based on that. The how these markets are more volatile, and at the same time the timings also, like the days, and then the time like holidays period, and then so some
Okay.
of the crucial periods in the in the yeah.
So it's applicable to all the timing or just for the volatile time?
This is basically our, the analysis on the volatile time.
Okay, can you go to a result part?
Mm-hmm.
What is the precision at 10?
Precision 10 is like, that is what is the top, top 10 of the, 1 second.
Yeah, it's fine, Krishnam. This is really good presentation. And I think, it's need to be tested on real-time data.
Right. Yeah, it's
Yeah.
not at not that level. Yeah.
Krishnam sir, I
Okay.
just would like to ask that what financial risk you're talking about? Is it the credit risk or system risk or the market risk that you're considering?
It's a markets, like, it is in the mostly the stock markets.
Okay, and also as we all know that it's very volatile market, financial market is very volatile. So why do you think
Right.
that GNN, you have used GNN, right? Graph
Right.
neural. So why do you think that it is suitable for this volatile market? Why this model?
I didn't get your question.
You have used GNN to
Right.
assess the financial market risk, right? So why
Right.
you selected GNN for this purpose? Why GNN model and why not any other?
No, the traditional models already there, right? That was showing logistic regression and
So
random
is there
forest.
anywhere where you have shown that there is a comparison between the traditional ones and the one you are using, GNN, that would suggest that your GNN is better than those traditional methods?
Right. In the presentation, I did not put all the things, but in the
But
paper.
have you gone with the comparison? Have you tested it with the traditional models also?
Right. We tested, and this is the proposed one, GCN and GAT within the GNN.
Okay.
Okay. Thanks, madam.
Thank you, sir. That was a great presentation. Thank you for sharing your perspective with us. Now I would invite paper ID 291, Abhiraj Singh Bhatia, on design and implementation of deep learning algorithms for automatic grading of student essays.
Good afternoon, chairs. Shall I begin?
Yeah, good afternoon.
Good afternoon, sir.
Is my screen visible? Just a moment. Just share. Now, is it visible?
Yes, it is visible.
So, good afternoon, chairs. Today, I, Abhiraj Singh Bhatia from BTech Computer Science Engineering Department, and along with my partner Lakshay Yadav, is going to present a PPT on the topic design and implementation of deep learning algorithms for automatic grading of students' essay. Beginning with the introduction, essay writing has been a critical part of academic assessment. So this presentation introduces to an advanced AI-driven system that uses deep learning and natural language processing techniques for automatic grading of students' essays. As we know, traditional essay grading methods are time-consuming and subject to human biases. Also, it has been subjective on large-scale assessments. So to overcome these problems, this project seeks to create an objective and scalable solution so that accurate and consistent evaluations can be provided. So these are the three objectives of our study. First one was to develop a hybrid model. We designed a hybrid model combining transformers and LSTMs to leverage their respective strengths. Transformers was for capturing global context and LSTMs for sequential dependencies. And second was our second aim was to improve grading accuracy by evaluating on 4 factors. That was grammar, coherence, argument strength, and content relevance. Also, we didn't want to provide students with just scores, but also meaningful feedback to improve their writing skills. Next is the methodology, data and pre-processing. We used a data set of over 10,235 lines of essay across various subjects and academic levels. So we cleaned the data by removing URLs and punctuation and special characters. Then we tokenized and normalized word cases and applied stop word removal and lemmatized to extract meaningful word forms. So these all steps prepared high quality inputs for our deep learning model. Next is the model architecture and training part. Our model combines of hybrid transformer and LSTM layers. The transformer component used self-attention mechanisms, while the LSTM focused on logical flow between sentences and paragraphs. Now, we use glove embeddings also to represent words semantically and in an order. And metrics such as the mean squared error and Pearson correlation coefficient were used. So we achieved an accuracy of about 83% on the model we choose for our project. Now this is the analysis, experimental setup and metrics that we used. Mean squared error, Pearson correlation, and accuracy. Mean squared error can be defined as how predictions are different from actual grades, how far it is from actual grades. And Pearson correlation can be defined how closely are predicted scores aligned with human evaluations. And accuracy of the model is the accuracy. Now we tried 4 models and we tested 4 models and we finalized hybrid transformer plus LSTM because of its low MSE and a good amount of accuracy, which was 83%, which was highest among all the models that we tested. So the hybrid model had BERT and GPT were also powerful individually, but were less effective, including in handling essay structure and coherence. So conclusion and research gaps. In conclusion, this hybrid deep learning model significantly improves grading efficiency and objectivity. It reduces the burden on educators and offers timely, consistent feedback to students. So the future works this model can be integrated into e-learning platforms for real-time essay assessment. Thank you. Any questions?
Now the forum is open for Q&A.
Viraj, that's a really good work. Can you go to your system design?
Just a minute. So this one?
Yeah, this one. Just zoom it or make it full presentation. This part.
Yeah, just.
Okay, this is a very well defined number of the thing. So Viraj, I want to understand one part here.
Yes.
If the essay is auto-generated, the generated by some model. So do you have a phase somewhere here which actually detected it is not written, it is a generated one?
No, sir. We have designed the working model also for this paper, and If you want, I can show you that working model.
No, I just want one question. If someone feed the auto-generated essay,
Okay.
what would be the response?
Sir, it will give the assigned grades out of 100, a
Okay.
percentage assigned out of 100 to that particular essay, and with the feedback also.
Okay, sure. So in my point of view, there could be, the way at an initial stage, if it's auto-generated, it is straightforward, say that, this is auto-generated, and it should not be evaluated.
No, sir, because even if you type an essay or it is auto-generated, or if you take an essay from somewhere, it will define the score to that one.
Okay, so you have a very generalized one, which will just give the rating to it.
No,
right?
sir. Yes, it will provide the percentage out of 100 and a comprehensive feedback to improve their writing skills.
But in the auto-generated essay, how it is related to a student?
No, sir.
Because the essay should be written by a student,
Yeah, that's a valid point, but the essays which are auto-generated, they will also get scores. But yeah, definitely they are not written by students. They have been taken from somewhere.
Okay. Yeah. Thank you so much.
Yeah, Viraj, I just would like to understand that what exactly do you want to do with this? Like, for example, I've written an essay. Your software is basically going to rate my essay. And if something needs to be changed, it will suggest me. Is this what you are suggesting?
Yes, ma'am. The comprehensive feedback will suggest on the basis of the writing skills, and the score that you will get from our interface, that will be the score assigned to you on your essay.
So what will be the criteria on which your model will be analyzing my essay? What all criteria will be there? Like creativity. I cannot see the creativity is one of the criteria, because that definitely matters, isn't it? Other than grammatical things.
Ma'am, yes, we have evaluated, we have taken 4 evaluation factors, that is coherence, argument strength, content relevance, and grammar, which we studied across the different research papers.
But I think creativity should also be one of the factors which should be added to this model.
Ma'am, coherence and grammar can be combined to get creativity. If you see,
my last question would be that why do I need your model for this? I can use ChatGPT to assess my document, my essay. It will give me the score also, and it is going to enhance my essay also.
I think, ma'am, this model can be used to overcome that the time used by the faculties. It is more time consuming, and human biasing errors can come. So I think this model has.
Basically, you're suggesting it for us so that we can check your question papers and it should grade you automatically.
No, ma'am. Question papers, I mean, different essays can be checked, but not the questions and not other questions.
तो essay writing बेटा कहाँ होता है आपके curriculum में, मुझे बताइए जरा. Where is essay writing included in your curriculum? You are pursuing what, BTech?
Yes, ma'am. Computer
so
science.
Do you write essays?
No, ma'am.
I think that is the thing which we used to do in schools.
No, ma'am. This we have not developed for for us students. This is for faculties who are teaching in schools.
Who are teaching in schools?
Yeah.
I think you should once again revisit what you are actually trying to design, because I think there is something missing in the concept. Okay. And we have better solutions available for this purpose if you are just specifically designing it for essay designing and everything. Okay. All the best.
Thank you.
Can we please move ahead with the next presentation?
Yes, ma'am. Moving ahead, paper ID 397, self-supervised learning for CFA 10 image classification by Shivam. Shivam, can please share your presentation, sir?
You on it.
Am I audible, ma'am?
Yes, sir.
Just a minute. Is my slide visible?
Yes, sir, it is
Hello.
visible.
Okay. So, good afternoon, everyone. I'm Shivam, and I'm a fourth year BE student at Chandigarh University. So, the paper I'll be presenting is self-supervised learning for CIFR 10 image classification. And let's go into the history first. So, in recent years, image classification, as we all know, is a critical part of many AI applications, from facial recognition to autonomous vehicles to medical imaging. So these things rely heavily on label data, which can be often expensive, time consuming in some domains. And in for some categories, it is quite impossible to obtain in large amount. So the just a second. So the problem statement. The problem which arises is like as I have said, it is almost impossible and very difficult to acquire these images. So our thinking was, so can a model learn meaningful visual features without label data? So, and if yes, and how can we make it learn efficiently while still achieving high accuracy? So, like deep learning models like CNN works best on trained data uh, with labeled data, but labeling thousands of images takes time. So, in deep learning, especially for tasks like image classification, getting a large amount of labeled data is time consuming. So, uh, the objectives of the paper. So the objectives of the paper is like our aim was to teach the model using unlabeled data. So it won't need the labeled data, and we just have to provide it with unlabeled data, and it will learn with by itself using self-supervised learning. So self-supervised learning, as we all know, is a growing field that lets model learn from unlabeled data. But most existing SSL methods were either too heavy, like one method was SimCLR, but it is only focused on one of the features, not like you cannot do with multiple features. So the solution we proposed. So the proposed solution is like we used a CFI 10 data set. It consists of 10 classes and a total of 60,000 images. Each image is of 32 by 32 pixel with the RGB images. And where 50,000 images are for testing and 50,000 are for training and 10,000 are for testing. And first, we'll propose two methods. So two pre-tasks with multitask rotation prediction and jigsaw puzzle with color permutation. So these are called pretext tasks because they are not labels, actual labels, but they are the guiding path to learn the classification. And we use TensorFlow to build it. So the first pretext task, which is multitask rotation. So in this, we rotate same images multiple times, like 90 degree, 180 degree, 270 at random, and ask the model to guess the correct order. This teaches the model to understand shapes, orientation, and how objects are positioned. And as for the second task, uh, we cut the image into 9 parts and like a puzzle, and we shuffle the parts and also randomly change the color channels, like swapping red and blue and other colors as well. So this model solves two problems. First, where the piece should go, where each piece should go, and where the color should belong. So this task help model to learn spatial relationship and color patterns, just like how we humans recognize where an image is. And this is the flowchart, like how making and training it to classify the image. So this shows step by step. We start with the CIFR 10 dataset, and we apply various data augmentations like random cropping, horizontal flipping, color jittering, Gaussian blurring, and then we pass the rotated image by rotating randomly to CNN encoder, which extract the spatial features, and then again we pass it to the another pretest task 2 to like randomize the colors and like divide the images into patches, and the model is then trained using cross entropy loss and mean squared error. So cross entropy loss, it tells how much our model predictions are wrong. So if a model prediction is wrong, we like give it a penalty, and we then it is also passed through CNN encoder. Then it extract the patch wise feature extraction, and then it is classified into image. So the architecture we are using, it is like we have three convolutional blocks with increasing filters: 64, 128, and 256. So each block looks for more complex features, and then the ReLU activation. So it just keep the positive values and detect patterns. And after each block, we add max pooling to shrink the image while keeping the important information. Then we flatten the features and pass them to a fully connected layer of 512 to 512 neurons. To prevent overfitting, we use dropout layer, and we use softmax layer to classify images into one of the 10 CIFR class in classes. And data augmentation, it is covered previously, but we use like random cropping, like select 80% of the image and resize it randomly. Horizontal flipping, half of the images are flipped. And color jittering, we change the brightness, contrast, saturation, and hue, so the model doesn't depend on just colors. And Gaussian blur adds slight blur to teach the model to focus on shape and not the sharp edges. And these were the results. Uh, so without any pretext task, the accuracy was 75%, but with rotation alone, it was 82, and with the pretext task jigsaw plus CBP, it was 85. But when we combined both by passing both sequential, it rose to 88%. And the evaluation matrices we use were precision, recall, and F1 score. They are increasing as we are adding the task, and at the sequential it grows to the maximum. And the conclusion, so our model builds our aim is to build a model and without labeling the data. So without label, we are reducing the cost of labeling, and but also achieving the accuracy of the labeled data. And the limitations are, we have only tested for CIA for 10 images, which is a small data set, but we aim to do it for CIFR 100 images, but at it is will be a like computation like resource. It would require a higher amount of specs for a computer, and it could be also improved for mobile devices like and like we in for future work we could use more pretext tasks and reduce the training cost. Thank you.
Thank you, Shivam. The forum is open for Q&A.
Yes, ma'am.
Thank you, Shivam. This is great work. So without unlabeled data, how you can train it? Can you just explain about it?
Sir, without labeled data.
Uh-huh.
So, sir, we are just converting it into a labeled data kind of, because we are using unlabeled data, and then we are training with it with pretext tasks. So rotation and
Correct.
the jigsaw CPP, and then we are
Right.
applying. So it learns what if the unlabeled image, even if it passed with an unlabeled image, it classify it as a labeled image after this process.
Okay. So looks like you are trying to pass the label data and performing a different operation, you know, to make sure it can understand what the image is.
No, sir. We are just applying the pretest task on unlabeled data and then classifying it into 10 categories for now.
Can you
What, sir?
there is a lot of noise in the background.
Uh, just a second, sir. Is it okay now?
Yeah, it's okay. So can you go to the your image where you did the segmentation of the image?
Sir, I'm not able to understand you.
Can you go to a few slide back?
Yes.
One more. Yes, here.
Yes.
Uh, Go to the next slide. Yes. Okay, so you are performing everything during a pre-processing time. Okay, that's
Yes,
fair
sir.
enough. Okay, yeah.
Shivam, can you just move on to your first slide where you have mentioned the
Oh,
title of your paper?
sure, ma'am.
Okay. So can you quickly explain what is CIFAR10 images and why you have
Uh,
specifically selected CIFAR10 images for self-supervised learning?
So, ma'am, these are the collection of 60,000 images, where 50,000 images are used for training and 10,000 are used for testing. So,
What images are
here
these?
the data set, like
Random
dogs,
images.
cat, auto. No, ma'am, it is divided into 10 categories, and each category contains a image of random that type of category, like automobiles. So, there will be a random car images
Okay.
and truck images, buses. That's
Okay. And how self-supervised learning is different from supervised learning and unsupervised learning and semi-supervised learning?
So, self-supervised is where we are just guiding it by using penalty methods, and so if it do a good thing, then we just provide it like with a thumbs up, and just, like it's okay. And if it does something wrong, so we give it a penalty. And as for supervised learning, here we guide everything. Like use label data, and we guide it through every process.
Okay. Understood. So, could you just tell me one thing? How does a system, a computer, understands the image? How does it read it?
So
If it's a straight
the
number, if it is an image, how does it understand that yes, it is an image of a cat or a automobile?
so it just the main thing depends upon the pixels.
Hmm.
First, if the image is high quality, and the pixel, like we are using 32 by 32 pixels here.
Okay.
So we are making computer learn, like
So you are making use of machine learning also there, right?
yes, yes, ma'am.
Machine learning and neural network is what you are
Yes,
using.
ma'am.
Okay. And once you are done with this image classification and all, and your system understands it, then what next?
So this data set, the unlabeled data set, it is passed through this system, and then it can be used anywhere like autonomous driving cars, and or it can be used in our mobile phone for like if we can scan any image or like user camera, and it would quickly tell us what kind of image it is. It just quickly classify it.
Okay, so what can
But
be the applications of this model? कहाँ use हो
so
सकता है?
it class first of all it could be used for classification, and where classification could be used, it could be used, just the difference is we are using unlabeled images instead of labeled images. So like medical imaging, satellite imaging, and robotics vision, computer visions, etc.
Okay, and do you think there is any privacy challenges involved in this, or there could be probable ethical and privacy challenges too?
Yes, ma'am. The problem could arise where we start using the data. Like if I integrate into a mobile phone, so it could use the image the user captured as like model. But the thing is, we just trained this model, and we are just classifying it. So the privacy problem that could arise is where we are training the model, and after training, if we are testing it, it is not using the training set for itself to like train it again.
Okay, so how
So
can
the
you
image.
mitigate? How can you mitigate those
Uh,
challenges?
So, ma'am, to mitigate those challenges, we have to like buy or like use unlabeled images, but make sure that those images are not like copyrighted from anywhere, and they should be copyright free. That's it.
So in that case, how will you know the authenticity of the data? Authentic है कि नहीं हमें कैसे पता लगेगा?
Hmm. Like there are various sources like if we use Kaggle, so they provide copyright free images and data, so we could use it from there.
Okay. Okay, thank you.
Thank you, Shivam, for your time and effort. Moving ahead,
Thank you, ma'am.
I now request Abhijit Pavle, whose paper ID is 134, Investigating Sustainability to Financing and Corporate Social Responsibility. Please present your paper.
Yes, ma'am. Thank you.
Please switch on your camera.
Yes, ma'am. Ma'am, is it visible?
Yes, now it is.
Is my screen visible, ma'am?
Yes, please start your presentation.
Thank you, ma'am. Good afternoon, all. I am Abhijit Rajendra Pabale.
You have to share your presentation also, Mr. Abhijit. Your slide is not visible. You are visible.
Okay, ma'am. Sir.
You have to share your screen using the screen sharing option.
Abhijit, were you not aware that you are having a presentation today?
Yes, ma'am. Actually, I was aware, but due to some family medical issues, I am right now out of station. So even I.
Abhijit? Ma'am, can we proceed? Meanwhile, he'll come back and join.
Has he left? Or he's there?
Mr.
If
Abhijit,
he
are you
has left,
still
we
there?
can go ahead with the next presentation, and if he joins in the midway, you can ask him to present after the
Yes.
session.
Right,
That
will
would
be
be
better. So then we can once move ahead to Mr. Ashutosh.
Yeah, Mr. Ashutosh Tripathi. I now request him to present his paper with paper ID 87, Enhancing Virtual Yoga Training Real-Time Pose Assessment with Voice Guided Accuracy Feedback. Mr. Ashutosh.
Hello, good afternoon. Can you hear me, ma'am?
Yeah, good afternoon, sir.
Ashutosh, we can hear you, but we cannot see you.
Okay, just give me a minute.
Okay.
Am I visible?
Mr. Ashutosh Tripathi, are you there? Ma'am, it's on mute. What do we do? Again.
No, Mr. Ashutosh was there, but then now he has got locked out. So maybe.
Sir, are you ready with your presentation?
Hello, can you hear me? There was some network glitch.
Right. So, Mr. Abhijit will have your presentation shortly because
After him.
In the meantime we had invited Mr. Ashutosh Tripathi to present since you got logged out. So, Mr. Ashutosh, you can go ahead with your presentation and then we'll come to Mr. Abhijit next. So, Mr. Abhijit, remain online.
Sure.
We'll come over to you next shortly. Yes, Mr. Ashutosh, you can share your slide and start with your presentation.
Is it visible to you?
Mr. Abhijit, just wait. Can you unshare your screen once? As told that Mr. Ashutosh is presenting currently, and we'll call you just after him.
Yes, sir. I've already unshared it, sir.
Right. So, Mr. Ashutosh, this is to you. Can you share your screen? Yes, it is getting shared. Yes. Can you make it full screen, your presentation? We can see the slide, but it is not full screen yet. Yes, now it's full screen. You can go ahead with your presentation. All the best, Mr. Ashutosh. Mr. Ashutosh, you are on mute. We can't hear you. You have to unmute your mic.
Okay. Sorry.
Yes,
So very good
start.
afternoon. Myself Ashutosh, and I'm pleased to present my work title, Enhancing Virtual Yoga Training, Real-Time Pose Assessment with Voice-Guided Accuracy Feedback. This research explores how AI and computer vision can bridge the gap between self-practice and professional yoga instruction through real-time interactive feedback. These are agendas of my presentation today. Talking about abstract, our system introduces a novel AI-based virtual yoga trainer that delivers real-time voice feedback to correct posture, unlike existing systems that rely solely on visual causes. We integrate joint angle-based voice corrections to create a hands-free, intuitive experience. This project basically demonstrates how computer vision and machine learning can surpass accessible and engaging and effective. Introduction, as we all know what yoga is, I'll give you a short brief. Yoga is a mindfulness with growing wellness needs. We have fast-paced lifestyle nowadays and access to personalized, flexible trainings, and yoga practice becomes more essential. Our system uses AI to mimic a live instructor, detecting body poses, calculating errors, and giving real-time verbal instructions. This offers interactive guidance at home, even for users without prior training. In yoga, some key features where we have detected pose, which give us accuracy analysis using media pipe pose module. We get voice feedback in real time with intuitive feedback while practicing yoga, performing yoga activities. Coming to literature review, prior research shows that CNN and pose estimation models like MediaPipe and OpenPose can accurately detect human postures. However, most existing systems lack interactive corrections. Our work built this gap on combining clarification, real-time angle deviation analysis. As you can see on the screen, these are some of different postures, different area between of the head is nose, and same way the rest of the numbers depicting the key points. This is improves alignment, but also boosts engagement. And hello. Sorry, I got logged out. There is some technical issue from my side.
Please carry on. Please carry on.
Your presentation has got unshared. You need to share it again.
I'll share it again.
Yes.
I'll share it.
Yes. Come.
Is it visible to you?
Yes, but full screen is not yet visible.
Yes, just put it on. Yes, it is visible.
Yes, continue.
Okay, sure. Coming on methodology, this is the methodology that we have created to proceed further in our research. As you can see, first we will be initializing the OpenCV media pipe and webcam that will be taking all the instructions and actions that will be given by the user. Then the main processing loop will process those postures. Moving further, capturing the webcam frame, it will detect the angles for the yoga postures. It will process the frame according to the pose, and our model will detect it, extract all the landmarks which we have entered into the model of our AI, and then it will calculate the angles, giving us accuracy. It will compare with the trained model and then calculate the correctness of the pose and the angles with which it is associated. Then it will proceed toward the voice feedback, where it will give out an it will interact with the user and speak out the loaded version of the voice we have already integrated in our model. It will correct the posture and speak out the correct pose that user should take to in order to correct his posture, his or her posture. Basically, will input the what we are doing in the webcam. It will be captured through a webcam. Pose landmarks will be detected using the media pipe pose module. Joint angles are then computed to check accuracy. A CNN classifier recognizes which yoga pose is attempted. When yoga pose is attempted, if deviations are found, uh, we have used PIT X3 that will use to deliver real-time voice feedback, and the sessions are logged for progress tracking. This is a system architecture that we are using. First webcam will be there, then media pipe pose estimation that will estimate the pose, joint angle analysis plus CNN classifications, and then deviation detection, going further towards the voice feedback, and then we'll track the progress and give the accuracy feedback according to it. Talking about implementations, our system was developed using TensorFlow for CNN-based pose, MediaPipe, OpenCV, and PTSX3 for converting text corrections into voice feedback. It currently supports 5 key yoga poses: downward yoga pose, downward dog pose, plank pose, tree pose, goddess pose, and warrior 2 pose. The CNN was trained on a curated percent overall accuracy. As you can see the graph on the screen, we have accuracy of different algorithms, naive Bayes, SPM, logistic regression, random pose classification details. The CNN model is trained on a curated yoga pose dataset, which we have took from Kaggle, focused on 5 yoga poses, as I have already told you. The output of the modalities is audio feedback and visual feedback, giving the accuracy. Pose wise accuracy is very much strong that we have found out from our model. The plank pose gave us around 95% precision. Warrior 2 pose gave us 91%. Goddess pose around 89%. Downward pose, dog pose gave us 88%. And tree pose gave us 86%. Plank performed best due to its stability. Tree pose being
Yeah, we completed.
Sir, should we proceed because he again got disconnected?
I think we can then.
Should we take a last presenter then?
We can go to Sir Abhijit.
Okay, sir. So now I invite Abhijit Pable, paper ID 134, Investigating Sustainability Through Financing in Corporate Social Responsibility.
Thank you, ma'am. Good afternoon.
Good afternoon.
Ma'am, is my screen visible, ma'am?
Yes, it's
Yes.
visible.
Good afternoon, sir. So I am Abhijit Rajendra Pable. I'm going to represent my paper on a topic sustainability through corporate responsibility, social responsibility. So in which what I've done is, sir, particularly nowadays we know that water is the most important ingredient, and due to its various forms of uses and wastage, it has become now a major, what we can say, a global problem to save the water. So in this, what we have done is basically what we are doing, we are using water in a concrete, and nowadays we know that concrete is the second most used material after water. So both are correlated to each other. Nowadays, due to industrialization, due to commercialization, and n number of things, concrete jungle has increased. And as there is an increment in use of a concrete, surely a concrete is a mixture of cements and aggregate and water in it. So what we have done is we are using water as an ingredient in order to prepare a concrete. So this water, that is the potable water, which is very lessly available on the earth nowadays, so that has to be particularly used into this mixture in order to make the concrete. So what we have done is we have found certain material which will make a partial replacement to this water, and that one material which we have particularly found is nothing but the distillery waste, spent wash waste. Now we know that there are sugarcane industries are available all over the world in n number of amounts. So these sugarcane industries, they uses a sugarcane as a what we can say a raw material in order to prepare the sugarcane, or we can say a sugar. So in order, whenever we are preparing a sugar, this sugarcane is used, and the byproduct from this industry is called as a distillery waste. Now distillery waste is particularly, if we can see, distillery spent wash is one of the most non-biodegradable material and hazardous material which is released from the sugarcane industries or n number of such industries in MIDC areas, which are directly released into Odha, river, nalas, which particularly pollute the environment, pollute the water, which directly or indirectly harms the aquatic animals and surely the life of people living around the vicinity. So if we try or if we consume such water, there are n number of diseases which takes place. So what I have done is, in my research, I have utilized that distillery waste as a partial replacement to the potable water. Now the potable water in concrete, we are using it, but is there any chance where we can partially replace that potable water with the help of distillery waste? So these are the assumptions, or these are the results, but which particularly which I got. Now firstly, we will first focus on what are the characteristics of distillery spent wash. So if you can see this, pH range is generally 3.9 to 4.3. That means obviously from the observation it is clear that it is acidic in nature. Then there are the nitrogen contents, phosphorus contents, potassium, calcium, magnesium, and if you can see, the last one is chemical oxygen demand, that is the COD. So now COD is the chemical oxygen demand, that is the bacteria which are available in that particular part, which particularly pollutes the environment. So if you see the amount, it is nearly 1 lakh to 1 lakh 35 mg per liter. So this is the quantity which is available in per liter. So that is a huge quantity which totally destroys the aquatic life, or we can say pollute the water, and that is obviously released into the rivers, odas and nalas by the industries. So there is no rule, even the CPCB pollution control board, even there are the strict guidelines, but the company owners or the MIDC areas or the industry owners, they do not follow the guidelines and they directly lay this water into the rivers. So this is the chemical oxygen demand. Then even in the second slide, if you can see the biochemical oxygen demand, so that is a BOD. So BOD also is a type of a bacteria which is available in that particular distillery waste. It is also available in the terms of 50,000. If you can see, 46,000 to 96,000, that means around 1 lakh mg per liter. So that is also a huge amount which can totally destroy the aquatic life or the people. If we drink that water, it will surely damage our system. So what we have done is we have partially, or we have tried to replace our potable water partially with that particular distillery waste. So some cube samples were prepared. In that particularly cubes, beams and cylinders were manufactured. So concrete grade which we used was M25. Type of cement which we used was OPC 53 grade. Nominal size of the aggregate was 20 mm. This type of exposure was severe. Degree of quality control was good. Degree of workability, it was 0.90, 0.9. Test data for materials. So the cement which we used in this particular project, so it was the OPC 53 grade. Specific gravity was kept as an 3.15. Specific gravity of fine aggregate was 2.38. Specific gravity of coarse aggregate, it was 2.60. Water absorption 0.81, and if fine aggregate, it was 3.98. So these were the results which were seen. Now there were some results which were carried out on potable water. So pH, obviously the water which is favorable for drinking with we generally human beings, is kept between the range 6 to 8. So 7.33 is the water which we particularly used in the concrete. Alkalinity, it was observed, which was 62 mg per liter, and hardness of the same was kept as an 225 mg per liter. Now if we can study the results, So these were the tests which were carried out on distillery waste. COD, as we discussed. So before treatment, in the bracket it is mentioned, before treatment it was 1,04,000 mg per liter. Before treatment, pH was 3.81, COD was 42,000. pH after treatment it was reduced, or it was came up to 7.50. BOD before treatment it was 46,000. After treatment it came up to 11,000. So majority of the ingredients which are harmful for human beings, aquatic life, and all those fishes and all those things, they were reduced after treating it. So this is the sample which we took from the sugarcane industry, that is of a distillery spent wash, and these were the cubes, beams, cylinders which were cast. These were the beams which were tested for single point loaded and double point loaded. Now, let us come towards the test results. Now, what we have done is we have tried replacing the potable water with distilled waste by 0%, 10%, and 20%. So firstly, we tried it for 0%, that is the potable water, that is the general. Now, in a world, the concrete which is prepared, manufactured, or which is used into the industries or the commercial structures, the same example was taken. So these were the results. In bracket, it is mentioned a potable water. So 3 beams were manufactured, 3 cubes were manufactured, and 3 cylinders were prepared. So after testing the beam under point loading, so we came to know that the load taken by beam 1, beam 2, and beam 3 was shown in the above amount was 3250 kg force. So the unit is kg force. So it was the force which was taken by the beam 1, beam 2, beam 3. Then for the cube, it was the compressive strength, which was 560 kilonewtons, 580 kilonewtons, 565. So average it is between 570, and cylinder is for the split tensile strength. So the average value was around 300 kilonewtons. Now the same water was considered, but 10% replacement was done with the help of the distillery waste. The same sample which is seen over here. So this sample was replaced with potable water by 10%. And if you can see the results, so in bracket it is mentioned partial replacement of potable water by 10% distillery waste. Now if you can see the results, the beam 1 has taken a value of 3575, beam 2 has taken 3450, beam 3 has taken 4275. Cube strength was around approximate 600 kilonewtons, cylinder was around 350. So this was related to the 10% distillery waste replacement. Now if you can see, again I have replaced it by 20% distillery waste, and I tried it what exactly the results were. So if you can see, these are the results. So we can see clearly that there is now a decrement in the load carrying capacity. That means the concrete which will be manufactured by inputting this 20% distillery waste will surely have a lesser value as compared to this value, that is the 10% distillery waste. So from the point, it's very clear that now some test results were conducted, XRD. So XRD results means actually I have sent this particular sample, concrete sample, into the laboratories, and I have tested it that what are the various ingredients which makes this happen possible. Because if you can see 20% distillery waste, the values are becoming lesser as compared to the 10% distillery waste. So after testing it into the lab or manuals, we came to the point that there are certain ingredients such as we can say biochemical bacteria, chemical bacteria, which after few days, let us say after 28 days, 56 days, they starts reacting with the concrete which is available in the particular environment. And the environmental factors, let us say that is acid wash or all those things, they again start reacting with the all these samples, and therefore there is a decrement in the result. So these were the samples which were taken for the XRD. So this was the XRD for 10% distillery waste, and this was the result wherein we found that a maximum load carrying capacity was increased. That is due to what happened is, if the 10% replacement is done due to the some favorable factors which are available in the distillery waste, it gives a priority, or we can say it gives a general workable factor to the concrete, which boosts or retards the energy. Therefore, it provides certain what we can say a strength gaining factor, which imparts some strength on the concrete, and therefore finally it gives the good carrying capacity. Now as we replace this by 20% of distillery waste, as these more acid parts starts reacting with the concrete and it starts deteriorating the concrete, the load carrying capacity, that means the concrete starts breaking from within. As it starts breaking, the obvious point is it starts declining or decreasing in the strength starts. So therefore, out of this particular, I came to the conclusion that the replacement of this distillery waste can be done up to 10%. If we go for the 20%, due to the deterioration and due to the corrosion, it starts giving the negative result. So these were the conclusions which particularly I got after testing these results. So if you can see the 7 point, this this research will create a substitute to potable water, which in turn will save the potable water, which is very precious for human being. Result shows increment in load carrying capacity of concrete if potable water is replaced by 10% of the distillery waste. Result also shows that load carrying capacity is increased by partially replacing potable water with 10% distillery waste. So these are the results which were taken, and also there are some future scopes which I am going to practice it, or which I am going to test. So I have done it for 10 and 20%, but now I will test it for 12, 15 and 18% to actually see whether there is some increment or decrement. So these are the future scopes which I will be doing. These are the references which I particularly gone through this part. Thank you, delegates.
Thank you, Abhijit.
Thank you, ma'am.
We welcome your questions, thoughts, or even challenges. Let's open the conversation.
Yes, ma'am.
Abhijit, sorry to hear you have some family issue.
Yes,
So
sir.
I hope everything is good.
Yes, yes, sir.
So it's really very good presentation. So only my question is everything is performed by you? All the
Yes, sir. Yes, sir.
testing?
Yes, yes. All the testings are done in the lab itself. I am an assistant professor working in engineering department. So basically, I am civil engineer doing PhD. So all the tests are performed in my laboratory itself.
Okay, and is someone validate those tests?
Yes, sir. CPCB, I have connected with the CPCB, and there is one lab, Dia Labs in Mumbai. So I have validated all the results with them. And there are some reference
Okay.
papers, sir. Reference paper also I have searched it. So results were matching.
Okay, that's really good. Best of luck.
Yes. Thank you, sir.
Abhijit,
Yes, ma'am.
firstly, it's disappointing that you are joining it from your mobile phone without
Yes, ma'am.
presentations.
Yes, sorry, ma'am, because due to the medical
You should have
emergency.
prepared, you should have kept your presentation readily available so that in any circumstance, if you have to give the presentation, you should be
Yes,
there.
yes, yes.
Or in case
Ma'am,
if there
actually,
is an emergency, you
yes,
should have
yes.
given it to someone else. I'm sure there must be 2, 3 authors in your paper, co-authors. You could have given
Yes,
it.
yes. But it was my guide, ma'am, and even I was prepared, but this emergency came very suddenly. So I requested it for tomorrow, but then I somehow managed it. And thanks to you that you have given opportunity, ma'am. And sorry for the inconvenience.
Okay, so just coming back to your title. What is the title of your paper?
Madam, it is a investigation of distillery waste if we try to replace it partially with the potable water. So it is a distillery waste, spent wash.
Sorry, just a second. What
Yes.
is the title of your paper? Investigating
Investigate
sustainability through financial.
financing in a social approach.
So how is sustainability and corporate social responsibility
Yes, sir.
related?
Yes, ma'am. Now, sustainable means we are finalizing or we are founding such a material which is sustainable in nature. Sustainable now, as we discussed, that water is readily available in nature, but nowadays the water scarcity has an n number of parameters, because nowadays, and also we have judged, or many of the officials have judged, that the third world war may be due to the water. So it is social and moral responsibility of every human being to protect or to conserve the water. So a sustainable material which can be found a replacement to water is welcome. So what I have done is, if we can even save a liter, or let us say if you are using 1 liter of water, and even if I can, or we can save at least 100 ml out of it, it will create some other material which is sustainable in nature. No doubt, the material is obviously hazardous in nature, that can be replaced to the water, and the sustainable approach can be brought. And that is obviously a social responsibility.
Okay, are there any source of financing for CSR activities going on already?
Yes, ma'am. Now about the availability of the distillery waste. So these industries, factories, they are readily what we can say dumping this waste into the.
Which companies or sectors are more active into this
Madam,
finance?
they are the private sectors, but that to the sugarcane industries and molasses industries. And primarily in India, if we can see, Uttar Pradesh state, Maharashtra state, Bihar state, they are having n number of sugarcane industries. Majority of the India is also a good exporter of sugarcane. So majority of the industries, they are directly laying water into the rivers. So if we can use that water, we will surely be capable of using, or we can finding a sustainable material. So this can be proved as an sustainable material, at least 10% in my project.
Okay,
So that
and
sustainability approach was achieved.
have you thought of calculating the ROI associated with these CSR activities?
Not yet, ma'am, but I will. It can be done, ma'am.
I think it should be done so that we can attract more companies to come into
Yes, ma'am.
the field,
Yes, ma'am.
right?
As it is a preliminary stage, ma'am. If these all
Hmm.
results will be positive, I am going to prepare a budget and I am going to hand over it to my state particularly. And if it goes further, then all these manufacturing, all these details can be published.
Okay, in your presentation, I think you somewhere mentioned greenwashing effect. Greenwashing.
Green,
So how does
environment.
greenwashing affects the perception of CSR funding?
Yes.
How does greenwashing affect the CSR funding or financing?
Now, ma'am, what is going to happen if, as you said, that if we make it a good, or if we publish the results, that is, if we can use a green material or a sustainable material like this, and if it gives a good output, that can obviously affect the CSR funding, because if we can able to convince the government or the people, they will surely give a good results to this. So it is at the preliminary stage, but surely if these results are published and if they are cross verified, it can be submitted for the CSR funding also.
Okay, so far there is no government intervention into this kind of thing.
Only the point is we have taken the official permission, and they have already, I'm in connect with the Maharashtra government, but the point is they said publish these results first. If they are flexible or if they are positive, then we will go for the frontal end. Likewise, and from the observation, it is very clear that 10% of the results they are showing good results. So already I am drafting a letter to the authority.
Okay.
Once it is approved, it can be gone for the CSR funding.
Okay, I think the topic is really good.
Yes,
And
ma'am.
I hope it gets accepted by the government authorities also.
Yes, ma'am. Yes, ma'am. It is in progress now. And ma'am, one thing which I again like to highlight, 10% was the replacement which shown good results. 20% there was a drop. But what
Actually,
now
we
I
could
have done
not
is,
see a presentation also. It was it was not legible.
yes,
Obviously,
yes, yes.
because you are sharing it through your mobile phone.
Yes. But the point is, madam, if 20% is giving some lesser results, there are some admixtures. If we use those admixtures, its strength will be again increased, and the cost of admixture is very nominal. So my point is, in the future scope, it may go up to 20 to 30%. And if we can, as I said, ma'am, even if we can say 100 ml from 1 liter, that is obviously going to save our potable water, which is very less available nowadays.
Yes, correct.
Yes, in India, if you can see, there are n number of states which are particularly in Maharashtra, Vidarbha, and all those things. They are really struggling for the water. So if we can save this water, it will surely give a good and a green impact to the country as well as the world.
Correct. Okay, so you are definitely working in the right field.
Yes, ma'am.
Because water is something we obviously need in our daily life.
Yes.
All the best for your project.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Abhijit,
Yes, sir.
so you were just testing with this water or some other water as well?
No, sir. Now, potable water is already tested. So this is the distillery waste. So now there are two types of distillery waste, sir. One is untreated and one is treated. Now, according to the Pollution Control Board, it is mandatory for all the industries to dump this waste after treating. So the cost of treatment, so the cost of treatment is already reduced. So only we are going to take that water and we are going to implement or partially replace it. The partial amount of water which is saved from that particular point will be used for the irrigation for drinking purposes. So the only distillery waste water is considered over here.
Okay. Sure. Yeah. Thank you so much.
Thank you, sir.
Yeah.
Thank you.
Bye.
Sorry for inconvenience, sir, and thank you for giving me an opportunity. Thank you. Thank you, ma'am.
Thank you for sharing your knowledge and expertise with us.
Thank you, ma'am.
As Mr. Ashutosh Tripathi logged out due to some reason, technical issues, I will now request our session chair and presenters if they have questions from him. Mr. Ashutosh Tripathi.
Yes, ma'am.
Please switch on your camera, sir. Is there anything else remaining?
Ashutosh, can we please see your presentation once again? Just a little.
Yeah, sure.
You can just share your slides once again.
Beta, where is the title in your paper?
Ma'am, it is here.
Enhancing virtual yoga training real time for the. So what exactly are you trying to do with this?
We are basically making a model that will help the user to interact with the system, where they'll be performing a yoga activity, which will our model will give them the feedback, a voice feedback, correcting their postures into a proper alignment. So for that, we have trained our model in such a way that the postures of their body will be aligned to that particular angle that is related to that specific yoga pose, and will give them the feedback, correcting them for the same.
So basically, we don't need a yoga instructor. You are suggesting us this
Yeah,
model or application so that we can correct our posture, right?
yeah, right, ma'am.
So is there any demo that we can see?
हाँ बोलो प्रांशुल. Good afternoon. Join किया हुआ है meeting?
धन्यवाद. ड्रॉप हो गया क्या? Ashutosh, are you there?
Mr. Ashutosh, can you hear us? I think his video has got freeze again. Mr. Ashutosh Tripathi, our voice is reaching you? I don't think so. He has got locked out again.
It was the last paper then.
Yes,
Should
because
we then
all,
close?
all other presenters have completed their presentations, and
I'm really sorry for continuously logging out. There's a
yes,
very
Mr.
unstable
Ashutosh, it
network in my
seems,
place.
are you logged in through Wi-Fi or through your mobile data?
I'm logged in through Wi-Fi. The connection is very stable at my.
Yes, it's again and again getting logged out. Moment you share your slides, either your video is getting
I'm
stuck
really sorry for that.
altogether, it's getting disconnected. So if you can quickly summarize your key findings to us, that would be beneficial. Then maybe if one or two questions
Okay.
connected with that can be taken.
Sure, sir. So basically, what we are trying to deliver is our system acts like a virtual instructor that combines real-time voice feedback and visualization. It significantly improves autonomous yoga practice by enhancing accuracy, engagement, and accessibility. We have achieved F1 score of around 86.4%, and adapt to different skill levels for different yoga poses. Most importantly, it brings interactive wellness training into any user that is using our model, and it is also a very critical need in today's digital driven world, where we don't get to exercise on a daily basis, and where we need any instructor outside, so they can significantly use our model to that will eventually help them to train and to have a experience in a right manner.
Ashutosh, I just have one
Yes.
question for you. Imagine that I am in the middle of this yoga session and my Wi-Fi fails just like yours is failing. So I'll be stuck in somewhere in very difficult posture. How you are going to solve that problem?
No, ma'am. The webcam screen will be blacked out if your network goes off. It will restart when you will log into it again. So you don't have to stuck into your position, but you will have to start it again. You don't have to be in that same pose.
So don't you think that it
Obviously,
would be
that will
better for
yoga is
me
a
to go
very
to the gym, hit the gym, rather than using your model?
It depends on the user, but for this day-to-day lifestyle, we don't generally get time. People are working 9 to 5 job, or
But
some
for this
of
also, we
them
will
are
have to
working.
devote some time, right?
Yeah,
Can we
right.
just sit
Little
in
time.
front of the
If,
camera and do the yoga poses? We cannot, obviously, right?
yeah, right. You can.
We are Okay, Ashutosh, thank you so much. That will be all from me.
Thank you, Ashutosh.
Alok sir, if you have something to ask, you can please go ahead if he's there.
No, I'm fine. Thank you so much, Ashutosh.
Thank you.
So, ladies
Before
and
you
gentlemen,
speak,
yeah.
want to thank Alok for timely joining the session and asking all those questions. And we hope that the researchers also learned a lot through the questioning. Okay, and also Dr. Anamika, who has been actively, asking probing questions to these researchers. Thank you very much for joining.
Thank
Yeah,
you,
it's my
Alok sir.
pleasure.
It was my pleasure to share the platform with you.
Same here.
Thank you.
Thank you so much to be with you. Thanks.
So that concludes our session. And what a remarkable series of presentation we have had today. On behalf of the IEEE Organizing Committee, I would like to extend our heartfelt thanks to all the speakers for sharing their time, expertise, and inspiring ideas with us. Your research and insights have not only enriched our understanding but also sparked meaningful discussions. We are truly grateful for your contribution. I also like to thank our speaker, session chair, Dr. Alok Jain, for his contribution in this conference. And to all the audience, to our audience, thank you for your engagement, attention, and thoughtful questions. Your presence is what makes this event so dynamic and valuable. Once again, thank you, everyone, and let's explore, innovate, and inspire together under the IEEE banner. Thank you, everyone.
Thank you, everyone.
IT host, you may log off and let's meet tomorrow at the same time.